Cool video.
Welcome, everyone, and thank you for staying. Just a reminder that today's call is being recorded. If you have any objections, you may disconnect at this time. Today's conference will begin shortly. Thank you.
Discovery, go and throttle up.
My favorite. All right, I'm just gonna take a leak real quick, dudes. I'll be back in a moment.
Hello, everybody. Welcome today. This is Karen Fox. I am with NASA's Office of Communications at NASA headquarters in Washington, D.C. Thank you so much for joining us on in some cases, a pretty short turnaround notice. We have a great panel today to talk about some opportunities with our commercial-public collaboration in terms of some of our spacecraft. I don't want to give anything away. You'll hear from our speakers who will give you more details. We will have each of them give a few minutes introduction, and then we will open up for questions and answers afterwards. The speakers today are Thomas Zurbuchen, the Associate Administrator for NASA's Science Mission Directorate, Jessica Jensen, who is the Vice President of Customer Operations and Integration at SpaceX, Jared Isaacman, Commercial Astronaut and Commander of Polaris Dawn, Patrick Krause, Hubble Space Telescope Project Manager at NASA's Goddard Space Flight Center in Greenbelt, Maryland, and Kathy Leaders, Associate Administrator for NASA's Space Operations Mission Directorate. With that, I will hand it over to you, Thomas Zurbuchen.
Well, thanks so much, Karen, and thanks to everybody who's taking time tonight on short notice. Before I launch into it, I want to acknowledge the devastation of Hurricane Ian as it continues to batter Florida and is moving off to other populated areas. Our thoughts are with the families of both the NASA workforce and those of our partners who are in Florida, who are, of course, part of our entire Kennedy Space Center community, and really the ride-out team at Kennedy Space Center is really at the top of my mind, and I hope they and residents of Florida, friends of our communities, are safe. It's an amazing time in space. We had this week this first collision experiment between DART with this dimorphous near-Earth object. We have amazing work that's going on around the space station with commercial crew and commercial cargo with our cross-agency partners and commercial partners enabling that. And what I'm going to talk to you about is really, if you want, the consequence of the investments and the work that my good friend Kathy Leaders and her team put into this for many years. And it is about Hubble. To start with, before I launch into really the discussion of what we want to do, I want to just tell you, reassure that Hubble is amazingly successful is healthy. It's doing great science as we speak. In fact, we just put a picture out that it took as, in fact, DART impacted into Dimorphos. And it's in its 33rd year. And frankly, Hubble is more exciting than ever because it now is a complementary asset next to the James Webb Space Telescope in a different frequency range, in a different, with a different viewpoint, really complementary going forward. So, but we're here today to talk about the exciting potential for public-private collaboration focused on Hubble. And frankly, a few months ago, SpaceX approached NASA with the idea for a study whether a commercial crew could help reboost our Hubble spacecraft into a higher orbit, one that would extend its observational lifetime and frankly take something off the minds of the AA of science in later decades where kind of end-of-life scenarios need to be considered. Today, we're announcing that we have signed a Space Act agreement with SpaceX to produce a feasibility study of exactly that, as well as some other tools that may be coming to bear, really what the benefits and risks would be to having a private team help support one of NASA's science missions, do so, recognizing the importance of this mission, the risk that comes from it, but also the benefit from that interaction. You'll hear from others today with more details about the arrangement and about Hubble. What I want to provide is a context of why we would sign an agreement like this. Of course, we have a large fleet of spacecraft within NASA's Science Mission Directorate of over 100 missions, 120 and counting, and every one of them is unique with its own goals, its own orbits, its own concerns. And as we go forward and we look at the emerging kind of commercial market, we always want to look at any and all possible opportunities to keep that fleet healthy and accomplish the science goal that NASA has. If private space industry might be able to help us with that, we want to know what the possibilities are, and we want to consider those. Commercial partnerships, we have learned, open the door for new and exciting opportunities for NASA's scientific exploration by offering new ideas and innovative ways to support them. NASA does not benefit from working solely in an echo chamber of ideas, frankly, but benefits from kind of exchanging those ideas openly and actively. It's important that we branch out and find ways to improve what we learn and really add new capabilities to our toolbox of options. I want to be absolutely clear. We're not making an announcement today that we'll definitely go forward with a plan like this. But we want to have a study to see really what would be feasible, future open doors and how NASA can think about supporting our own fleet with Hubble and other missions as we go forward. The data gathered from this study is another tool in humanity's toolbox that we can use to support future science missions and keep Hubble at the forefront of scientific discovery. So Jessica, why don't you go ahead?
Thanks, Thomas. That was great. Yeah, you said it so well, but also from the SpaceX side, we are so proud to be a part of these public-private partnerships that have led to so many amazing things. Yeah, like I said, the DART mission, commercial crew, cargo resupply, all of these have been amazing ways to kind of keep revolutionizing the space industry, and we couldn't be happier to be a part of it. So a little bit more onto the study. Oh, and I will say also, the hurricane impacts, we're thinking of all of our friends in Florida, all of our colleagues, just everyone in that state who has been impacted, and hope them all a well recovery after the storm leaves. So first, we're super excited for the opportunity to conduct this feasibility study with NASA. One of our main goals out of the study is going to be to take a closer look at how Dragon can safely rendezvous, dock, boost, and then therefore extend the Hubble Space Telescope operations. We obviously have a lot of experience rendezvous and docking with the International Space Station, so we want to use that as our foundation, but then innovate upon that. Hubble's different. It's in a different orbit, it's a different mass, different vehicle. The detailed proximity operations, that's going to be a little bit different. It'll all be unique to the telescope. And really, we're just looking forward to studying what's possible and what's needed and working all of this in coordination with NASA. Overall, SpaceX and the Polaris program together, what we want to do is expand the boundaries of current technology. We want to show how these commercial partnerships, as well as the public-private partnerships, can creatively solve challenging and complex problems. Missions such as servicing Hubble basically are going to expand our overall space capabilities, and all of this benefits the entire community and helps us achieve our goals of becoming a spacefaring and multiplanetary civilization. So I just want to give a huge thanks to NASA for continuing to partner with us. It's truly an honor. I will turn it over to Jared Isaacman.
And thank you so much, Jessica. I first want to just begin and say what an absolute honor it is to even be on this call today. You know, so over the last few years, what we've witnessed is just an impressive pace of progress across the aerospace industry. You know, pioneering technology like rapidly reusable rockets has really begun to reduce the cost to orbit to such an extent that commercial space missions are now really possible. And alongside NASA, exploration is one of many objectives for the commercial space industry, and probably one of the greatest exploration assets of all time is the Hubble Space Telescope. So while my comments are a bit specific, please remember, you know, this study has broad applicability. But that stated, you know, with James Webb Telescope now online, Hubble's mission has only gained in importance. So it's absolutely exciting to think about the possibility of extending the life and capabilities of one of our greatest explorers. So Polaris is excited to assist in this study, and hopefully it does lead us down a path that ensures Hubble's ability to continue to serve science for decades into the future. Thank you.
Thank you so much. We will move on to Patrick Krause.
Hi, thanks for having me on this call as well. I'd like to repeat and emphasize that while Hubble is being discussed as a model in this this feasibility study, repeat that Hubble is doing great. After more than 32 years, Hubble remains incredibly productive scientifically, with unique capabilities for exploring the universe and the unknowns in the universe. Hubble, using those unique capabilities, working in tandem with James Webb Space Telescope, enables greater productivity than either of the missions alone would have achieved working on their own. As a joint mission with the European Space Agency, Hubble has had more than 1.5 million observations to date and generated more than 19,000 peer-reviewed science papers, so arguably making Hubble arguably one of the most productive scientific instruments in history. In the past year alone, Hubble has released an image of the farthest individual star ever seen. The light of that star left over 12.9 billion years ago to reach us, and has also observed the largest comet nucleus to date, a 4 billion-year-old relic from the early solar system. As Thomas stated earlier, Hubble images of the DART impact into Dimorphos this week, the first ever in-space test of planetary defense. Those images are available today. So even though Hubble has been on orbit for 32 years, its orbit was originally about 380 miles above Earth and has slowly decayed over time due to atmospheric drag to its current orbit of about 335 miles. So Hubble has benefited greatly from the 5 servicing missions that it's had, and it's fitting then that Hubble is used as a model for this study, and we're excited to be looking again at new and innovative ways to keep our mission at the forefront of the scientific discovery. We will ensure that the feasibility study addresses Hubble safety throughout, any sort of servicing or boosting scenarios that the study will consider. Thanks to the improvements of those past servicing missions, we expect Hubble will remain operational until the later part of this decade, if not into the next. And again, I'm excited and look forward to the results of the study as the agency explores new possibilities for the future of its science missions.
Thank you so much, Patrick. We will have our final speaker of the panel, Kathy Leader.
Well, wow, I can't tell you how exciting this is. Here we are getting ready for our Crew 5 mission to the ISS. And yes, I am one of those hunkered down in Florida waiting for Ian to pass. But I'm really struck by, here we are talking about another use for this capability. It's just seen it come to fruition, because when we developed the strategy for Commercial Crew, our goal was to develop a LEO crew capability. that also, hey, safely and reliably flies our crews to the ISS. And so we hoped that we could also spur innovation and other LEO uses with this capability. We've seen that so far with Inspiration 4, and now here we are talking about other potential uses. So, I'm really proud of the work and the investment that NASA and our industry partners have made. And I'm still looking forward to continuing to see that being leveraged and expanded on. And finally, I'm going to finish up where Thomas started. I'm one of the lucky ones that still has power and not having flooding. So our hearts really go out to those already impacted by Hurricane Ian. And those, obviously, that may continue to be impacted. It's actually why we do our science and observation that we do, is to hopefully one day continue to find ways to be able to safely notify and help people from these kind of weather events. But I know there's folks out there that are having a really tough time right now. Thank you.
Thank you so much, Kathy. We will move on to questions and answers. Reminder, you press star 1 to get into the queue. And
fellas, you know how I usually don't have questions. I have questions this time around. So it looks like they're gonna try to boost Hubble with Dragon, but it could be with anything. Remember, this is a feasibility study, so I guarantee you half of the answers to these questions that the press is gonna have is gonna be like, well, we don't know yet.
Maybe Jared. I mean, is the ultimate goal to actually use a Polaris Dawn mission to reboost Hubble? And then a very quick one for Patrick Krause. What's the latest projection for HST's entry, given what we know about the solar cycles at this point anyway? Thanks.
Yeah, so Jared Isaacman here. I guess I can answer the first part of the question. As was stated on the call, I mean, the idea is a study at this point, not just for Hubble, but just broad applicability of these type of potential servicing missions within low Earth orbit. That stated, if the study, takes us down a path where a mission is possible, this would certainly, fit within the, kind of the parameters we established for the Polaris program, and certainly would build upon, the Polaris Dawn mission.
Yeah.
And the second part of that question, this is Patrick Krause, is that right now, the last projection we had in this past year was that we had a 50% probability of reentry in 2037.
Discovery, go at throttle up.
all right, thank you so much. Our next question is from Michael Sheets with CNBC.
Hi, everybody. Just wanted to dive in a little bit deeper there. Obviously, Jared, you guys haven't mentioned a specific stated goal for the second mission of the Polaris program. Do you, in your discussions that you've had with others here, and maybe Dr. Zaburkin or Kathy can tie in a little bit more here on their side of things, but have you guys talked about the possibility of the second Polaris mission using a Dragon, if this study sees that as being feasible? Maybe you can just walk me through a little of the specifics of where this would fit within what you guys have already outlined on the Polaris side of things. Thanks.
Sure. So, Jared Isaacman here again. I mean, the Polaris program was all about technology demonstration, either new capabilities that are going to be necessary in furtherance of the objective of making life multiplanetary, or utilizing technology or capabilities that haven't been demonstrated in quite a long time. The Polaris Dawn mission has an EVA, it has an altitude component. These are all things that I think naturally you could build upon and could be applicable to a second Polaris mission that would that could ultimately, should the study go in that direction, be flown. And I'd certainly kick it over to the NASA or SpaceX team if there's anything to add.
From NASA's perspective, here's Thomas. I want to tell you, I mean, we did not in all detail, Jared, you can confirm, talk about what your plans are with every one of those missions. I mean, I think we're just looking really at this in this study as what the potential is to really have impact for Hubble or for other space missions that are out there, like Chandra, for example, another really capable mission that has lifetime issues. So no, we did not, from my end, certainly dive into details for what Jared's plans are or SpaceX's plan. Neither do I think that's appropriate. I think it's really what their responsibility is and so forth. It's really focused on this study alone. Kathy may have a different take at it.
Oh, no, I think you covered it well.
Hey, this is Jessica from SpaceX. I can jump in as well. One of the things we look for whenever we're doing new developments are, we're going to do this feasibility study with NASA, with Polaris, and it's, part of it's going to be figuring out the cost and figuring out a little bit of the schedule. What's it going to take to actually make this happen and make it happen safely? Because nobody, we don't want to do something that's going to put Hubble at risk at all. So once we figure out a little bit more on schedule and cost, at that point in time, we could try and figure out what mission we should, if the study shows good, then it's from a cost and schedule perspective, what mission do we assign it to?
Thank you so much. I will move on to the next question, which is Chris Davenport from the Washington Post.
Hi, hello everyone. Good afternoon. Thank you. So I'm wondering, is this study simply to look at the technical aspects of how this boost would happen? Or are you also going to look at if there are any legal constraints that you need to work through in order to make it happen? I'm just wondering if there are issues, if you have private citizens and a private company working with really sensitive government property, or is this just like hiring any other contractor to perform a service? Thanks.
Hey, this is Jessica from SpaceX. I think the main goal is going to be technical. So the main goal of the study is going to be a technical feasibility study. From a legal and liability point of view of what you're talking about, SpaceX currently docks Dragon to the International Space Station, which is just an incredible worldwide asset. So I think from a legal perspective, government perspective, we worked these type of things before and we can get through those things. We may touch on them a little bit in the study, but the main goal of this study is just going to be technical. Is it even technically feasible to do this with a Dragon spacecraft?
Okay. I have nothing to add from Thomas.
All right, thank you to you both. Moving on to the next question, which is coming in from Marcia Dunn with the Associated Press.
Yes, hi. Jared, are you volunteering for this mission if it's seen to be feasible? And would you be taking NASA astronauts with you conceivably, and when might that happen?
Yeah, I think just to reiterate kind of the points that have been made throughout the call, I mean, really, we're just on a study at this point. I'm certainly hopeful that the results of the study support a mission to, extend the life and capabilities of, again, one of the greatest exploration assets, for humankind. So, I think we cross the bridge on who's ultimately, flying it if the study ultimately supports embarking on a mission.
Thank you so much. Next question is from Nell Greenfield-Boyce with NPR.
Hi, thanks for doing this. So how much does this study cost, and who exactly is paying for this study, this feasibility study? And also, I mean, Hubble's been great, but to my knowledge, a repair mission was not the priority, and it sounds like this is something that SpaceX approached NASA about. I mean, I'm just wondering, is there going to be a perception that this is like, to be quite frank, like rich people looking for something to do in space and sort of like settling on Hubble? And, sort of, did you guys have any concerns about how the public would respond to that?
This is Thomas. We think about any and all aspects of work we do. I think if somebody looked at it from the outside and basically should, in fact, as Jared said now a couple of times, right, the study have a positive outcome, I think together we would look even more at what all the elements are for such a decision, including some that were mentioned here. At this moment in time, there's no transfer of funds for this feasibility study. NASA and SpaceX are funding their own participation of it, and I think it's wholly appropriate for us to look at this because of the tremendous value this research asset has for us as well as others that we could consider.
Thank you, Thomas. Our next question is from Alexandra Whitsey with Nature Magazine.
Hi, thanks, Karen. My question is for the Goddard representative. There have been lots of studies over the years about potentials for robotic servicing, boosting of Hubble. How much, in terms of altitude boost, might this study be looking at from, for instance, from 335 miles to what? Oh, and is servicing part of the study too?
Right. So what we looked at, we understand that there's potential cost to reboost from, say, 335 to back to 375, 380 miles. Forgive me, I typically think kilometers. There's up to 600 kilometers. I think that's 375, 380 miles. And then the feasibility study will, in conversations with SpaceX and Polaris Dawn, we'll have some conversations about if there's potential enhancement capabilities that we can add on. But we haven't looked at anything specifically at this time.
Enhancement like servicing?
Yes, a potential servicing capability will be part of the feasibility study.
And do you mind if I just add, Pat, if it's okay, do you mind if I add a sentence to that, what you just said?
Sure.
Needless to say, I from the science perspective, consider what we did with shuttle, and servicing Hubble, one of the biggest kind of victories of really the agency as a whole, right? Bringing astronauts to bear and doing these amazing kind of changes of the instruments and all kinds of complexities. I just really want to make sure that everybody understands that as we start this study, I think we're starting at a point that is not at the level of sophistication kind of in our experience base that we were at the end of the shuttle era. And I think it's just really making sure that we're all just really recognizing that as we look at safety of both assets, that we recognize, kind of that, each step that we, if the study comes out that way, if we decide to go forward, each step will be considered, and then each one of the lessons, even though it was possible in the past, will have to be regained, kind of with new technology, with new partnerships. In other words, don't expect what we did the first time. That is not the right kind of proof point to get started, right? Jared, or Jessica, you may want to add your own comments on this. I just really want to make sure that people, when somebody says servicing, it could mean all kinds of things.
Nothing to add from my end. Thank you.
All right, then. We will move on to the next question, which is from Tim Fernholz with Quartz.
Hello, thank you for taking my question. It's for Kathy. When private astronaut missions go to the ISS, NASA requires them to be accompanied by a former NASA astronaut. So I'm curious, if a mission like this were to go ahead, would you require a employed or former NASA astronaut to participate? And I'm also curious, what would the value of a mission like this be to NASA, and would you be willing to pay for it?
Well, I think the first thing is, when we were talking about the private astronaut missions to the ISS, the reason we're looking at, and we just updated the requirement set, was really to make sure that the operations on the ISS were kind of maintained as seamlessly as possible, really to kind of protect the science aspect of what we need to do on the ISS, and making sure that the people that were going on the private astronaut missions, had somebody that had flown before and been able to help on those missions. Now, that's also, obviously a requirement. We continually look at our requirements, and as we go through and continue to work our private astronaut missions, we'll assess that requirement going forward. But right now, it's the best thing for us to do to keep the very complicated operations on station going as seamlessly as possible while we have, 4 new crew members on board that are fairly new, some of them, to the on-orbit environment. I think folks have said probably like 4 or 5 times, we're just beginning the study of this. So I think that, we're kind of just stepping into it, assessing technical feasibility of it. I would say the questions you kind of asked at the second part of the question, I think, would be things that we would be fleshing out as things matured. And I don't know, Thomas, if you would want to add anything.
I really don't have anything to add, Kathy. This is Thomas, of course. I think the only thing I want to tell you is that whether we look at investments of any and all assets and kind of any and all capabilities in science, we look at the decadal guidance as a strategy, as one of the key ingredients, how we do that. And so that would be, as we go forward. I want to remind you also that, of course, the Nancy Grace Roman Space Telescope that's launching later this decade is, we have, of course, communicated previously, can be serviced as well. So that capability is definitely something, as an agency, we're interested kind of in the long term, but right now we're doing this study at no exchange of funds.
Thank you so much. We will go to our next question, which is from Jeff Faust with Space News.
Hey, good afternoon. I'm curious, there's this whole emerging industry of in-space servicing, companies developing capabilities to reboost or service spacecraft. Will those capabilities be assessed by NASA at any point in this process before making a decision to proceed with SpaceX for a Dragon mission to Hubble Space Telescope to see if that is in fact the best option to reboost or service Hubble? Thanks.
I think that might be a question for Thomas.
Look, as we get through this study with the boundary conditions that we've now repeated a bunch of times, if we make a next step, we at NASA look at any and all options that are in the interest of the taxpayer, and we should.
Thank you so much. We will move to Kenneth Chang with the New York Times.
Hi, thank you. What's the timeline for completing the study? I want to get some clarification. Who's doing it? Sounds like SpaceX people, but they'll also be NASA people. And notionally, how might this occur? I mean, Dragon does not have a robotic arm.
Hey, this is Jessica from SpaceX. I can answer that. So this is a 6-month study with NASA. So both of us will be, I'd say predominantly on the SpaceX side, we're going to be looking at Dragon capabilities and how they would need to be modified in order to safely rendezvous and dock with Hubble. So yeah, details of exactly physically how that's done and how we also safely do that from a trajectory point of view, that's all to be worked out.
All right, thank you so much. Moving to the next question, Eric Berger with Ars Technica.
Hi, thanks for doing this. 2 questions. I guess one is for Patrick. How much has Hubble's orbit degraded since the 5th servicing mission in 2009? And what do you consider a healthy altitude for observations and longevity? I think you mentioned 600 kilometers, but I wanted to clarify that. And then for Thomas, how many of Hubble's IMUs or gyroscopes are presently operational? Is it 1? Is it 2? I mean, I know that this is just a study, but obviously it would be pretty great if you could replace that. Would that be within the scope of the study, looking at potential options like replacing a gyroscope to add longevity? Thank you.
Patrick, why don't you answer the second question also, Thomas speaking. Go ahead.
I might have to have the second question repeated to me, but
how many gyros are operational? He asked.
Okay. So Hubble orbit was about between 560, 565 kilometers at the end of servicing mission 4, and we're now down to just under 535 kilometers. So we've dropped about 30 kilometers since 2009.
Not bad.
Right now we have 3 gyros operating. So Hubble had been during servicing mission they had put in 6, 3 of which are what we call enhanced gyros, and it's those 3 enhanced gyros that are still operating, and we expect to operate for quite a while.
And Eric, the Thomas speaking here, the parameters of the study certainly would enable the team to look at that as one of the questions to address.
Thank you. Our next question is from Joey Roulette of Reuters.
Thanks for doing this. First question for Dr. Z and Kathy Loiters. Have any other companies or countries pitched this idea to NASA, or was it just SpaceX? And when this study concludes, would you guys consider doing some other kind of program to look at other companies or other capabilities to service or boost Hubble? And then one for Jessica Jensen. What does SpaceX get out of this study? Will this experience, I guess, inform how you guys plan to dock tanker starships in orbit or other things that aren't the ISS? Thanks.
Joey.
So you want to take this, the first one?
Nope. Not letting it bother me. Nope.
Well, I think, Thomas, maybe you can talk about the original study. I mean, I think Thomas and I, when people come in with ideas of things that would help us go look and investigate on how to solve any potential problems, this is not an unusual thing for us to go do feasibility studies and short-term things to go look at things. This to me is the first outside assessment, but Thomas, you can correct me if I'm wrong.
Yeah, Kathy, first and foremost, we're working on crazy ideas all the time.
Yeah.
And frankly, that's what we're supposed to do. I hope you agree, all of you, that we're always supposed to push the envelope. This is really compelling because, a commercial partner came to us with an idea, and over time, we've had others come with various ideas. This is certainly in the area that we're talking about quite unique and first. So I'm not aware. Remember, I've only been the agency for the 6 years, and not everybody only talks to me, but I'm not aware of another kind of idea in this kind of comparable to this one kind of brought to NASA. I also want to just point out that we have tremendous plans with our both commercial partners with our agency assets, and that is with Artemis to go to the moon, right? There's a lot of goals we have that we need to achieve. So kind of for us, the priority certainly with our commercial partners is kind of to enable both kind of commercializing low Earth orbit, but also doing these. So it's certainly not the case that many of us feel that we have kind of a whole new kind of the way you asked the question, kind of a whole new kind of strategy that we would want to pursue on top of what we're already doing. It's certainly not on my mind at this moment in time. But we should always look at what's out there and explore and see how we can add value to our assets and to our exploration programs.
It'll be a shame when you retire.
All right, to extend upon that and answer the second question, what does SpaceX get out of this, Jessica? So first of all, Hubble is a national asset, and it's really an honor for us if we would be able to extend its lifetime. So I think first of all, in the near term, I think that's just a great goal in itself. But SpaceX really sees the future in that we are a spacefaring civilization. And that means that there are spaceships flying all over the place, there's on-orbit refueling, there's vehicles from various companies, there's space stations from various companies. We do things like service very expensive spacecraft in higher orbits. We continue to service telescopes. We build bases on the moon and Mars and do all kinds of things. And so when you look forward to this spacefaring civilization, missions like this where companies are learning to adapt and figure out ways to dock to older vehicles and to, basically make two vehicles in space compatible with each other that weren't initially designed to be that way. I think that's an amazing capability, and that's how the industry needs to move forward.
Thank you. Moving on to our next question, Marina Corin with The Atlantic.
Hi, Marina Corin with The Atlantic. Thomas, you mentioned that SpaceX approached NASA with this idea. Can you tell us who at SpaceX did that? Or Jared, was this your idea? And for Jessica, I know you need to do the study first, but a Hubble boosting mission sounds like something that maybe an uncrewed Dragon spacecraft could potentially do autonomously. So I'm wondering why you'd even need asteroids, too much DART mission coverage. I'm wondering why you'd even need astronauts in this kind of effort, or is this something that you anticipate would require EVAs? Thanks.
Marina, Thomas.
Or go ahead.
Go ahead,
Thomas.
Go ahead, Jessica. Go ahead, Jess.
I was going to say, again, as part of this study, if there could be something that comes out of the study that says, hey, it does not make sense to have a human mission going to do this. So we're going to look at all the different options. We'll keep, at this point, everything is on the table. That's part of feasibility studies, and that's part of development.
And Marina, I need to probably get back to you because I don't remember exactly what the first discussion was. It's a couple of discussions here and there, in various contexts. I don't really remember who the first one was. I'm sorry. Perhaps somebody else can answer it. It's an idea that was ready to be had. So a number of people started talking. I don't remember exactly who the first one was. I apologize. I'll see whether I can go through my notes and answer it better later, Karen. I just really don't remember at this moment in time. And there's a number of discussions that happen with various people.
Thanks. So, Marina, if I hear more from Thomas, we will get back to you specifically with an answer on that.
The PAO's
in
name
that
must
case,
be
let's
Karen.
move on to the next question, who is Stephen Clark with
The
Space
PAO's
Right
name
Now.
is Karen, I think.
Thanks for taking my question. I think my questions will be for Patrick Krause. I know the last shuttle servicing mission attached the soft capture mechanism to Hubble. Would that be something that could enable a Dragon to dock without using a robotic arm to grapple the telescope? Just talk about the importance of adding that to the telescope to make something like this feasible. And if you don't reboost Hubble, when would be the earliest NASA might have to consider doing a deorbit mission or planning a deorbit mission for Hubble? Thanks.
So yes, the inclusion of the soft capture mechanism in Service Mission 4 certainly makes a mission like this much more feasible and easier to talk about. And it's going to be part of the feasibility study is to see how that adapter is useful and what kind of accommodations may have to be made since that even that design now is a little bit out of date of what the agency is using for docking mechanisms. But it certainly does provide an opportunity for a direct docking, we believe, without the need of a grapple arm necessarily. What was the second question? Sorry.
It was about when would NASA have to start planning end of mission scenario.
Right, and so NASA is always looking at studies and making plans and considerations. Right now, we're sort of carrying that in the later half of the 2020s. We would have to be having consideration of a mission that would then be ready to launch, say by the end of the decade, to go up and perhaps attach a propulsion system. But that's all notional at this point. There is no official mission that's been designated. the studies continue.
Nothing to add. Nothing to add from my end. I just want to say I feel really strongly as to my colleagues here at NASA that really when an asset of the size of Hubble comes to an end, that we think of end of life in a careful fashion and kind of one that considers people on Earth and also the low Earth orbit as a resource. That's it.
Thank you. Moving on, our next question comes from Jim Siegel with nasatech.net.
Hi, everybody, and thank you for taking my question. I think this is a question for Jared, and maybe Jessica will have something to add. I believe my readers are pretty well acquainted with SpaceX, but not necessarily with Polaris. So could you describe for my readers what Polaris does and how SpaceX and Polaris would be complementary in this sort of endeavor? Thank you.
Sure. So Jared here on that. I think where we could be complementary when you think of Polaris and SpaceX to this type of effort is we could be taking advantage of everything that's been developed within the commercial space industry to potentially execute on a mission should the study warrant it, with kind of little or no potential cost to the government, which you would think would be of great benefit to just all of humanity if you can extend the life and capabilities of an asset like Hubble or potentially other assets as more of them are launched into low Earth orbit. And in terms of just Polaris in general, Polaris was announced earlier this year in February as kind of a partnership with SpaceX to undertake a series of tech development missions. The first of which is Polaris Dawn, which should launch towards the end of the first quarter of next year, and that has a number of components to it that are pretty important for, hopefully enabling and making life multiplanetary. So an EVA, an altitude component, new method of communication. But the idea was, at the time of the announcement, there will be a second mission, of which it's certainly possible the study could result in this type of mission becoming the second Polaris program, and then the third is the first crewed launch of Starship, which certainly would be demonstrating quite a bit of new technology along the way.
And just to add to that from the SpaceX perspective, we've been honored to work with Jared and the Polaris team. Really think Jared pushes us to very creative solutions, and this kind of goes back to the whole point of how people from diverse backgrounds really can come up with the most innovative ideas. And overall, these innovations hopefully push space technology forward. It may push technologies forward that some of us just didn't think about or kind of been stuck in the back of our heads, and now we have a reason to accelerate and have a reason to do things. All of this hopefully lowers the cost for space travel in the future and just makes the access to space easier for everyone. So I really like the way SpaceX and Polaris work together. I think just benefits the industry all as a whole.
Thank you so much for your answers. Our next question comes from Mike Wall with space.com.
Thank you all. This is probably for Patrick. Yes, you were saying you were kind of looking for a 30-kilometer boost, if this does happen, and I'm just wondering what sort of difference would that make to the longevity of HSP, and also just in terms of sort of framing this study. It seems like you at first just described it as a boost feasibility study, but it also seems like servicing is going to be part of it too. So is it safe to characterize this as a feasibility study of using a private commercial vehicle to both boost and also service Hubble? Just to get some clarification on that. Thank you.
Right. So the feasibility study, one of the things we'll look at is what is the maximum boost we could achieve. Preliminary assessment has been on the order of 40 to even say 70 kilometers of boost. Certainly, if we were to get back to 600 kilometers, that's essentially the altitude we were at in 1990 when the mission was launched. So you'd add easily 15 to perhaps 20 years of orbit life to the mission if you could achieve that altitude. In terms of the study, yes, we're looking at the idea of the feasibility study would be to look at, again, using commercial technology, commercial partners. Those look at it from a boost opportunity, but also feasibility. What kinds of things might you be able to do with the servicing aspect? And as Tom has indicated, we certainly wouldn't anticipate being at the level of complexity of some of the servicing missions that were accomplished, with the shuttle and the NASA astronaut crews from the past. But we certainly are excited to look at what opportunities are available with our commercial partners.
Our next question is from Raman Skiba with Wired Magazine.
Hi, thank you. I think this question is for Jared Isaacman and Thomas Zurbuchen. I just wanted to follow up on some earlier questions since this doesn't really feel like a traditional contractor partnership. I was wondering, if this feasibility study came to fruition, could you give any more detail about how this potential relationship between NASA's space program and Polaris Dawn might work? I mean, for one thing, and Jared Isaacman, no offense to you, but you're, not a scientist or engineer or career astronaut, nor in a leading position at SpaceX or NASA. So, like, what is your, role there?
Yeah, I think it's a great question. I mean, and really, I would just point you back to the Polaris program and what was announced earlier this year, which is it's a series of tech demonstration missions done in partnership with SpaceX. There are specific objectives that we're trying to achieve with each mission. Certainly, the idea of boosting and servicing Hubble, should the feasibility study support it, would be, a logical second mission. But beyond that, the bigger goal is, helping to deliver on SpaceX's vision to make, life multiplanetary. So, the conclusion of the Polaris program is the first flight of Starship. And that obviously in itself could be a key enabler towards SpaceX's vision. As for my individual involvement, look, I'm just happy to be on the line right now. I think this is incredibly exciting about what this study could ultimately lead to. And if myself and the Polaris program can play a small part in that, it's a pretty good outcome.
This is Thomas. You asked earlier about what contractual vehicles and so forth that we could use. Of course, the answer is, you can guess, right? We have not discussed that because we haven't decided what's coming out of the study. There's a number of vehicles available to us, and needless to say, should we get to the other side of that and need such a vehicle, we'll have a whole set of them available to us. So that has not been discussed, and neither should it have.
Thank you. We do have quite a number of questions left. Unfortunately, we are going to have to end promptly at 5:30, so we'll get through as many as we can, but some of our panelists need to leave promptly at 5:30. Our next question is Leah Crane with New Science.
Hi, thanks for taking my question. I was wondering if this does work out and we are able to boost Hubble, could we just keep doing this forever? Are there other limiting factors beyond needing a boost?
This is Thomas, and of course, I'm going to ask Pat to go right after me. There's multiple things that limit the lifetime of a spacecraft. Sometimes it's propulsion. In this case, it's the orbital altitude, but there's other things that also age over time, such as the gyros, I think we already talked about. So in other words, the devices that keep the spacecraft, the ability of the spacecraft being pointed. There's computers that over time pick up more radiation and therefore become less effective or perhaps have challenges. And the instruments, filters, for example, can get less transparent over time. A whole slew of issues like that are being considered by Pat and his team on a regular basis, and it is true that the orbit is one of them, but it's in no way the only one that relates to the lifetime of Hubble. Pat, go ahead.
Yeah, you said it pretty well there, Thomas. I think as a consumable, right, the orbit is the obvious thing as we're degrading. Hubble, some of the instrument detectors, they get used up just by using them, and so eventually those will become we'll lose the ability to capture significant signal to noise. But the most things that we're focused on right now are the life expectancy of the gyros, life expectancy of fine guidance sensors. We do see wear and tear. So it really is just ongoing aging of the spacecraft components, electrical parts. We have reliability models that we look at, and of course we work, as Thomas said, very hard every day to try to mitigate the aging scenarios with the spacecraft. So we won't last forever, but we're trying to last as long as we can. And as we said, we think we have reasonable expectations of being able to operate productively through the end of this decade and into next decade, we believe.
We are just going to have time for 2 more questions. Our next one is from Robert Perlman with Collect Space.
Thank you. For Jessica and Jared, can you give a sense of how long this idea has been in the works at SpaceX and Polaris before you approached NASA? And Jared, you mentioned that the Polaris Dawn mission includes some technology demonstrations that might be applicable to a mission like this. Did this idea for a study predate Polaris Dawn and help inform what you would do on that mission, or was it born out of what you're doing on Polaris Dawn?
I'm happy to start that off and then would kick it back to Jessica for anything additional. I would say that when we were giving consideration to what we could accomplish on the first Polaris mission and what that could lead us to for a second mission, the idea of potentially a Hubble servicing mission was one of the ideas up for consideration. So I'd say there's been a lot of thought and energy that has gone into this idea long before, we kind of arrive at this point, just to make sure it was, still in the realm of possible. But considering what we're aiming to accomplish with Polaris Dawn, it does seem like there are things that we can build upon from that mission that would be, applicable to what this study might ultimately determine as appropriate.
Good words, Jared. Nothing to add from me.
Great. And as I said, we just are taking one more question today. For those we didn't get to, please do feel free to contact us, and we will try to get your questions answered. Our last question today will be from Manuel Mazzanti with Debate.
Thank you so much. I think my question, Jessica answered my question a few minutes ago, so I understand that the study will involve or will take a decision if this needs to be a crewed or an uncrewed mission. But I guess if it's safe to assume that if it ends up to be a crewed mission, some kind of servicing can be done. And I apologize if this was mentioned before.
Yep, I think that's all part of the study. We want to benefit Hubble, and if benefiting Hubble is not just boosting it, but also providing some servicing, and that can be done with the human spaceflight mission, all the better. So it's all on the table right now, and as we get into the study, we'll have to figure out some of these things and see what's possible.
Well, thank you so much. I appreciate everybody coming to this press briefing today. As I said, if we were not able to get to your question, please feel free to contact us directly, and we will try to get you an answer. And in the meantime, you can check back at nasa.gov when we'll keep updated as we have updates. Thank you so much to everybody for being here today, and we'll talk soon. Thanks. Goodbye.
All right, you hang up first, NASA.
Bye, everybody. Thanks so much.
No problem, Dr. Sepulkin. I will see you next time. Seriously, though, that is going to be a very bad day when he retires, because I really appreciate Dr. C's candor in the matter. Yeah, he sounds like Gunther Steiner. I told you. People didn't listen to me. Sounds like Gunther Steiner. He comes from the same part of Europe. Actually, Dr. Z is, I believe he comes from Switzerland. Yes, that is where he is from. So, all right, fellas, once again, I'm trying not to let the press questions bother me. Trying not to let it ruin my day. With that being said, I'm pretty sure that there's a lot of people that don't understand what a feasibility study is. So let me explain. A feasibility study is basically, usually in the past, a feasibility study comes after what's called an RFI. So it in NASA speak, it's called an RFP. That's what the feasibility study is. This is technically, if you wanted to put it on paper, this is an RFP. But in this particular scenario, it seems like SpaceX and NASA had been talking about this, and they went past the RFI right to RFP. Now, what does RFI mean? Request for information. These RFIs get put out on NASA's website, and they are a BAA RFI, a broad agency announcement, request for information. Basically, NASA has, as Dr. Z said, NASA has a bunch of people that are, a bunch of scientists and engineers that are trying to push the envelope. They're trying to come up with different ways. They're trying to do things differently. Like, let me give you an example. If we were going to crash a satellite into an asteroid, how would we do that? How would we do it? So they put out if they can't figure it out, they'll put out a broad agency announcement. Okay? A broad agency announcement RFI, basically saying, hey, we're not entirely sure about the best way to do this. We're putting out this request for information, and these RFIs are, RFIs don't really last very long. It depends on what you're doing. They basically say, if you were going to do this task, how would you do it? Like, are you capable of doing this? So, like, if NASA was putting out an RFI on Hubble servicing, for instance, they would be like, look, is there anybody out there that thinks they can attempt to go and service the Hubble Space Telescope or go and boost the Hubble Space Telescope? And if so, how would you do it? Right? Keep in mind, RFIs are very general. Okay, it's very general stuff. It's not like, it just establishes stakeholder expectations, and that's about it. Like, if we were gonna do this, how would we do it? Right? Then comes RFPs, requests for proposal. RFPs are basically like, okay, we need a more detailed explanation of, if you were going to do this, how would you do it? That's what this basically is. It's a feasibility study. So the feasibility study, basically it looks like SpaceX has been whispering sweet nothings into NASA's ear about boosting Hubble for a good while now. Thanks, Orion. Yeah, it seems like they've been just kind of talking about it in the background. Like, SpaceX basically said, hey, we move people to the space station. Why don't we get some Hubble servicing up in there? And NASA's been like, yeah, I guess maybe sometime, dude. So it looks like they finally said, all right, if SpaceX kept proposing that, what NASA probably did is they probably did their own RFI, like an internal thing. Like, okay, they probably went to the Hubble Space Telescope program manager there and probably said, hey, is the satellite in condition to be, like, in a good condition to be boosted? Could we do that? Project guy that runs the project, I don't know, man, maybe give me a second, let me figure it out. And by that, I mean they do kind of an internal thing, like, could we boost this, could we boost that, and could we service that, what shape are the gyros in, etc., etc. That, notice how they had all that information handy, like what gyros are working, what wasn't, the orbital decay over time. That was done in an internal NASA study based off of what SpaceX was asking. Basically, SpaceX went to NASA over time and said, hey, we should boost Hubble. We should boost and service Hubble with Dragon. It makes perfect sense. You're already paying us to move people to the ISS. We should do this too. It's a good idea. And you get more science out of it. Right? And then NASA said, all right, we're gonna do this, like, would the satellite be capable of doing that? And then, you know, like, that's what I mean. The Hubble Space Program Manager was there, and he had all the details on the satellite basically out on a piece of paper. He was answering them right off the bat because that was from their internal study. So, once again, this is a feasibility study. It's kind of like an RFP, but because of the circumstances in which this was made, it didn't really come up as a broad agency announcement. So, now, I mean, keep in mind, feasibility studies can happen between RFIs and RFPs. It does happen. It really depends. There's no, like, concrete way of doing this. There's just a general way of figuring out missions for your space program. So, what's a feasibility study? Okay, feasibility studies start with what's called a stakeholder expectation. So, that would have been my question. What are the stakeholder expectations for this study? Eric's the one that got the closest to that question. What are your stakeholder expectations for this commercial study? He asked it in a weird way because he doesn't know what a stakeholder expectation means. But he asked basically the same thing. Yeah, Berger asked my question, believe it or not. So the stakeholder, like, he asked what's in the scope, like what is in the scope for this, which kind of, I mean, that's kind of my question, but it's kind of not. NASA probably, well, Tessa, NASA would have done an internal study to see the feasibility of the effects on the satellite if we boosted it, or if we docked something to it, would it screw up the gyros or something like that? Yeah, Urbanus, this is systems engineering. This is systems engineering. Every big engineering project or system engineering project or a mechanical engineering project starts with stakeholder expectation. This is what I try to drill into you guys' head. Not why did you do it? What are you doing? What are you doing? WhatsApp, what are you doing? What are you trying to do? What are you trying to get done? Straight up. You're trying to, why don't we just take Hubble and move it over there? There you go. There's your stakeholder expectation. That was the primary one. To be honest, they did say that right at the beginning. I don't think there was a good amount of people there that were actually listening to that, but whatever. What do you expect to get done from what you're doing? Bingo. Yep. How likely would it be that NASA would answer questions from you if you drop an email to their press department? I don't know, man. But yeah, that would be my big thing. They kind of went over it, but I'm like, what are the exact stakeholder expectations for this feasibility study? Or are the stakeholder expectations not really figured out yet? That's why this is weird, because this doesn't really follow the typical kind of process for how missions that are associated with NASA get done. There's no RFI. There's no broad agency announcement. There's no RFP. This is just a partnership for a feasibility study. And now, this is a part they made sure to mention, and this is a really important part. RFIs, RFPs, feasibility studies, no money gets exchanged. There's no monetary transaction here. Nobody is paying anybody for any service at all. During RFPs, RFIs, stuff like that, no monetary exchange, and that's really important to understand. You don't start exchanging money unless you have a contract. Now, I'm not going to sit here and say that doesn't apply to real life. You like buying a house, for instance. You really want to make sure you have a contract before you start handing money to people. Yeah. The tax man pays for it. Yeah, you seem to want to, be like, oh, the tax man pays for it. But SpaceX is basically spending their own money to do this feasibility study. NASA did some internal studies regarding the matter, but I mean, yeah, of course the taxman's paying for it. Like, it's NASA. It's like driving around on a smooth road and being like, taxes paid for this. It's like, yeah. I mean,
Discovery, go at throttle up.
Yeah, so? I mean, extending the life of Hubble arguably is a very good use of our tax dollars. You know what I mean?
Go at throttle up.
Hey! Liptodon smiles. Thanks for the 5 subs, dude. I appreciate it. Thank you very much. Why does SpaceX want to do it, though? They're hoping for a commercial Hubble maintenance plan? You know what? Rook said this the best. Alleviate. What it was after that guy asked him, "Oh, no offense, but you're not a scientist. You're not an engineer." Yeah, I know he's not. He's a pilot. He's a pilot. He's a commander of the mission. He's a pilot. And what is he qualified for to be a pilot? Oh, I don't know. He flies around fighter jets for fun. I'm pretty sure he knows how to fly a plane. Like, you know. So, thanks for teaching me a lot over the last year. My pleasure. My pleasure. So, Alleviate, I'll get into that in a second. So, okay. So, Alleviate, Rook answered that question. He answered the question, but he kind of did it not speaking exactly for SpaceX because he didn't want to speak for Jess. Jessica Jensen is a VP of. Hang on, I have her title here. She's a VP at SpaceX of, I think it's marketing. I think, I could be wrong. Jess Jensen is the Vice President of Customer Operations and Integration. Okay, yeah. So it's not marketing, but it's close. So, I'm a pilot. I can fly. So, why does SpaceX want to do this? Well, Rook answered it in that thing, and then Jessica answered it a second after, like a little bit after that. Basically, SpaceX is anticipating an emerging market where satellite servicing is going to be a market trend. They're anticipating a commercial low Earth orbit market where satellite servicing is the new hotness. Commercial space stations, scientific satellites. SpaceX wants the equity in their company. Does that make sense? They want the expertise. That is why SpaceX is valued so ridiculously high. That's why a lot of people that are critical of Falcon 9, for instance, say, "Oh, they'll never turn a profit on that. They're never going to turn a profit on reusability. Reusable rockets don't make sense." Funny, there's people still say that nowadays. The truth of the matter is that they're probably right. But even a blind squirrel finds a nut every once in a while. They left it at that and didn't do any more thinking about said subject. Of course, SpaceX is launching at a loss. Duh. They have to have all the boats and all the cranes and all the integration equipment that they otherwise wouldn't have if they were just expending Falcon 9s. They already built the factory. They can make as many as they want. Duh. Of course reusability is, they're not making profit off of it. The profit literally comes from somewhere else. It comes from Starlink sales. You don't need to be a mathematician to figure that one out. Now, with that being said, do Starlink sales offset the profit of reusing boosters? Maybe. Maybe not. But if it's one thing that I've noticed with SpaceX is that the expertise is the profit there. The expertise is the profit. Hear me out. Has anybody else been able to deliver people to the ISS commercially? No. When did commercial crew start? 2014? Yep. They're the only ones that can do that. That's what I mean about the expertise. That's a very in-demand skill set right now to have. At least from a corporate standpoint, right? They're the only ones that can do it. They're the only ones that can launch people into space. There's 2 other spacecraft in the world that can launch people into space right now. Soyuz and Shenzhou. There you go. The other thing is that Falcon 9 was never meant to be profitable. It was never, I don't even work at SpaceX, I can tell you that. It was never meant to be profitable. The expertise in understanding what it takes to reuse a rocket, that, it is the profit there. So when you actually go to make your next generation rocket, you can incorporate reusability and the lessons learned from reusability directly into its design. And then achieve full reusability. That's always been the plan. Elon said this in like 2015, 2016, something like that. I'm pretty sure he said that at some point. I can't cite a specific example, but that's always been the plan. So why does SpaceX want to do it? Because they're anticipating a market. They're anticipating a market, just like they anticipated reusable rockets. But, I mean, the interesting thing, and this is for the skeptical people, that reuse technically still hasn't been proven. You know what I mean? But it seems like reusability is here to stay. There are market trends in the commercial market now that kind of reinforce that. So Starship, there's Neutron with Rocket Lab. There's Terran R with Relativity. There's fishing out electron stages. We're not fishing them out. Parachuting down electron stages and Rocket Lab again. There's a lot of other companies that are also trying to pursue reuse. I'm positive that within our kid's lifetime that SpaceX will turn a profit. If anything, Emerald, it is going to be with Starlink. Starlink has insane potential. I mean, are telecommunications more... do telecommunications make more profit than launching things into space? Yeah, absolutely. Telecommunications is $1 trillion industry. Launching stuff into space is $1 billion industry. Yeah, no, it's smart, man. Yeah, Vulcan with smart reuse. There you go, Sumo. Yep. So, think about it. At least every satellite SpaceX put up there, they can send people to service. They could. Yeah. So they want the capability. They want SpaceX even though there's no money exchange, they want the capability so they could do that when people actually need their satellites serviced, other than Hubble. They basically want to learn how to do it with NASA on Hubble on their satellites, and NASA's a good avenue to do it because they already have a pretty healthy customer relationship with them. Yeah, NASA pays SpaceX a lot of money to move people to the ISS, right? So that's the answer to that question. Now, the second part of this, dude, is not the second part. The other part that I was talking about. What is a feasibility study? A feasibility study depends on stakeholder expectations. So I heard a couple of different things that could be interpreted as stakeholder expectations through that entire press conference. Yeah, exactly, Oculus. We fix Hubble, we can fix your satellite as well. I don't see anybody else with that capability, right? Oculus, I would like to add that the next logical step there is downmass capability. Oh, we can fix your satellite, but if it's broken, we can bring it back. Hint, hint. Now, what did I hear for stakeholder expectations? Well, there's a couple of different things, and some people in the press kind of honed in on it. But they were like, if you could boost it, could you service it as well? Well, they don't know. That's why they're doing a feasibility study. But stakeholder expectations seems to be boosting Hubble and potentially doing a servicing mission. The primary thing seems to be boosting the satellite. That's the big one. Now, so it really centers around boosting the satellite higher and service operations. So could that entail an EVA? Maybe. Depends. Operations are anything that's not just like boosting the satellite. I mean, technically boosting the satellite is an on-orbit operation, but I'm thinking about Sentinel-1B. That would be a neat ability to have. I mean, Alex, I told you guys, I've always, I have my theories on making a healthy, sustainable, like, low Earth orbit economy. And the backbone of it could be servicing science satellites. Only my idea was a climate science satellite network. Make Landsat, a network of Landsat satellites that are gigantic modular satellite buses, and then send Dragon up there and have people install and uninstall new components. If you design it around, if you put like a small hab module, right, on the back of said satellites, right, like just a little habitable volume, not like anything that you can live on. You live in the capsule docks to it, and then have all the guts of the freaking satellite right there, so you don't need to be outside. You don't need to be outside to work on it. Or conversely, maybe you have a vehicle with a payload bay, and you can bring the satellite into the payload bay. That worked last time. Yeah. So that's what I mean about feasibility. They're not sure exactly how they're going to do it, but it basically goes off of like the big stakeholder one is boosting the satellite's orbit. They're not too worried about it from a hardware standpoint. The hardware, what's that guy's name? Patrick Krause. Patrick Krause said that the hardware is good for another 10 years easily. And it could be even longer if they put it in a higher orbit. The satellite is set to decay in 2037. Yeah. Hubble's got a lot left to give. Chris B was thinking about a dual launch servicing scenario with a crew and a cargo Dragon. I mean, yeah, Jessica Jensen said basically everything is on the table. I'm sure some of this feasibility study would be with Dragon, potentially Dragon XL, could be with Starship. Could be with Starship with crew on it. Could be Starship with a robotic arm, unmanned. Heck, I'll bet you the feasibility study could even include bringing that thing back down. I'll bet you they add it, because if you can rendezvous and dock with the dang thing and boost it, well, if you're doing something like that with Starship, you're going to boost the satellite when it's inside of the payload bay. Am I right? That's what they did with the shuttle. They had the thing sitting in the payload. Sitting in the payload bay. Just a thought. Aren't the gyros going out? It has 6 gyros on it, Yarg. The 3 of them were upgraded during the last Hubble mission. And those ones are working just fine. It's the 3 older gyros that aren't working correctly. You know, it sounds an awful lot like right to repair, like making your cell phone, laptop, or tractor looking at you, John Deere, easily repairable. Modulars, well, satellites, because, you know, mass is at a premium, Orion, are generally, and satellites really don't have multiple uses. You build it for the one use and then you go from there, like a radio antenna, right? So it's kind of like that, but for different reasons. So, yeah, SpaceX is Jess Jensen basically said that everything is on the table. So, yeah, that's basically what a feasibility study is. SpaceX is just going to figure out, okay, what are our primary goals? The primary goal is boosting Hubble Space Telescope. That's the stakeholder expectation, with the possibility of being able to work on it in the future. And then I would even throw, as a secondary stakeholder expectation, as a stretch goal, bringing it back down. That I would throw that in there, because if you're going to do those first 2, think about that think about the third one too. Why not? You're already there trying to figure out things. You might as well figure that one out too. It won't take very long. So, in terms of operations, what's done with these mission architectures? Like, how does this work? How do we do that? How do we how much detail are they going into? They're not very much detail. This is basically getting the corner pieces of the puzzle, so to speak. You know what I mean? You find the corners first when you put a puzzle together, right? Tactile 3D, thank you for the raid. Appreciate it. So, SpaceX is exploring all options, and they're just going to try to figure out a general feasibility study to see if they can actually boost Hubble and maybe even work on it. Now, I see you guys already going to this point. If you were working at SpaceX right now, how would you do this? Those first 2 could be accomplished with either Dragon or Dragon XL. Bringing it down necessarily requires a Starship. We're on different beasts there. Yeah, so? Thanks for the raid, Tack. What were you up to? Depends on what Hubble needs. Is it just a boost and reaction wheels? Nope, no, Motorkid, you already jumped the gun. You already jumped the gun. You know your stakeholder expectations. Okay? You know your stakeholder expectations. The Hubble, we heard from Patrick Krause there that Hubble is good. It is okay to be able to be boosted, and there are multiple avenues to do it. Hubble has a grapple arm fixture for a latching end effector for the shuttle's robotic arm. It also has an additional grapple point that was installed on STS-125 on the last Hubble servicing mission. Or was it 129? Forget. On the last Hubble servicing mission, they installed a grapple fixture so something could grab at it that doesn't use the latching end effector. You're playing KSP TAC? That's cool. Right on, man. Appreciate the raid, buddy. So, it's a latching end effector, Sebi. The space station's RMS could grab at it too if you could somehow do a gravity and get it over there, but that's probably never going to happen. So, how would you do it? I know how I would do it. Yeah, I know how I would do it. I already have something out and about in my head. So Dragon. The Dragon capsule, right? This thing. The Dragon capsule. Obviously, right? So I know people are going to have questions. So I see two ways you could do this with a dragon, with what I know about dragon. Now keep in mind, this is a thought exercise. I don't know anything about this mission any more than the information that was just presented. Nothing more than the information that was just presented. This is a thought exercise. We're just kind of entertaining the idea. If we were going to go get at Hubble with a dragon capsule, how would you do it? Well, there's a picture of Hubble. Where's that grapple fixture? I forget where it is. Yeah, STS-125, servicing mission 4. There's the NDS grapple point right there. See that? So, something that I kind of noticed here. You see the pedals down here? They're right above my head. There's the grapple fixture. The other thing that Hubble has is they have the active latching system points. This is where it was mounted inside of the space shuttle's payload bay. So the shuttle passive latch, those are active and passive latching points are there. I need to look at one more thing. Okay, how did they latch this thing when it was like this? Okay. Hubble servicing missions were insane, dude. In a good way, in a good way. Wouldn't that bump into the nose cone of Dragon? Yeah. So I just pointed out the grapple fixture there. That's an NDS grapple fixture. That wouldn't work because of the nose cone. Unless Dragon could get at it from one side and have the nose cone kind of go out over the edge. Here, you might be able to get at it. The other thing I noticed is that grapple fixture is not on the longitudinal axis of it. So boosting it from that port is probably not a good idea. So here's my idea. Here's what I would do. Once again, this is a thought exercise. I'm just kind of snowballing ideas. Now, a lot of people don't know this, but Dragon actually flies backwards through space. Its primary propulsion system, so what it uses to go forward in space, is 1, 2, 3, and 4. I don't think I need to explain why, if you dock to Hubble, even if you could get the nose cone around it, why that wouldn't really work too well. Now, Dragon does, if these are the reverse thrusters, Dragon does have forward thrusters, but they're pointing out. My mouse cursor is on them. So the forward thrusters on the nose cone point this way, right? And then the thrusters that are on the sides point that way, right? They're angled out because they need to go around the heat shield in the trunk. You don't want to use those to boost things. This is part of the reason why Dragon can't boost the ISS. Or it's really not going to work too well if it tries to. Because those are the thrusters it needs for boosting. Those are on the longitudinal axis of the vehicle. They're on the longitude axis. So you fire those things. They actually alternate them when they fire them to manage thermals. But that Dragon actually flies backwards through space. Yeah. A lot of people know that. You don't want to use these thrusters because that's not very efficient, because they are on the longitudinal axis, but they're pointed out. So that's not as efficient, because out of the impulse that comes out of that thruster every time it's fired, it's 45 degrees offset to the direction that you're trying to go. So those are only really used to hit the brakes, basically. So deploy a frame to to attach the latches on Hubble out of the trunk. Is there a design reason why the dock is canted like it is? Why that's over there? Because they have to latch it in the center. They couldn't install it right on the center axis. They had to install it on the side because the center was being held by that thing. So, if Dragon has to go in reverse, right, and it has to dock to Hubble, and it likes to fly backwards through space, and it has an unpressurized cargo volume in the back, put that in Dragon's trunk. Put this in Dragon's trunk. That's it. Canted, bent downward. What's bent downward? And then use these thrusters to fire and boost it. That is seemingly the easiest way to do it. Does having stuff in the trunk mess with abort capability? No. The station side docking adapter. Oh, that. That's a pressurized mating adapter. Yeah, I was getting confused, Rares, because we're talking about this and not that. But the pressurized mating adapter, the PMA. I could give you a bunch of different reasons why that thing is bent down like that. Yeah, there's a bunch of reasons for it, but here. I'll just show you this picture. It'll make sense. Does that answer your question? Did I miss something? Are they sending Dragon to Hubble? Odd job. NASA just announced a feasibility study with SpaceX to look into potential ways to boost Hubble's orbit with SpaceX. And Jared Isaacman was there. So they haven't announced it because I don't think they're sure exactly how they want to do this, but also, yeah, but also no. I don't know what Quantum Leap is, John. Here's a higher quality version of the servicing picture. Okay. Yeah, I basically... Oh, it's a TV show. Neat. Rares, does that answer your question? Did you see the photobomb in this picture? Yeah, of course. Yeah, that should show you the scale of the space shuttle. Spoiler alert, it's a lot bigger than you think it is. Does it have to be Dragon? No. Rares, this picture gets the point across pretty well. If you're not understanding why the pressurized mating adapters are bent down like this, the main reason is so when you're trying to dock the shuttle, you can see the docking port. You can see it. The shuttle had a manual docking system. There was no automatic docking with this thing. No, too old for that. Every dock to the space station was done manually. It's done with somebody sitting at the back of the flight deck with the RCS offset controller right here, right? If you look at the back panel on the space shuttle, there's the right side is docking, the left side is the arm controls. And there's two windows on the back of the shuttle that look into the payload bay, and there's two windows here that look out. Those windows are there on purpose. They're there so when you're far away, you can look out and you can see the port. And then when you're good for final docking, you literally look right at the docking port from the side to get it to dock. That's why these things are bent down. So you can see it. You can see the dang thing. Yeah. Also, yeah, if you see the guy sitting on the flight deck of the shuttle in this picture, yeah, that shows you how big the thing is. Yeah, see the dude right there? It's big. The shuttle's huge. What are the odds that they're already designing a boost package for Dragon? I mean, that's the other thing. Dragon could deploy a boost package out the back of its trunk, right? That's a little bit more of a complicated mission than just using Dragon to attach it and then turning Dragon around and docking it. But then again, you don't want Dragon. You want Dragon backwards like that. That's not going to work. Because the thrusters, your forward thrusters are pointing at Hubble, right? So a lot of you guys have said, oh, launch a Dragon XL, and Dragon XL will have something that can dock to the Hubble, and then Dragon will come and dock to that and then boost it. Well, you run into the same problem there. Your thrusters are pointed in the wrong direction. So they might not even have Dragon there. But also at the same time, it could be done autonomously. However, and you guys tell me if I'm reading too much into this. They wouldn't have Jared Isaacman there. They wouldn't have Rook there if they weren't pretty dang sure that it had to be a mission where crew is required. They wouldn't do that. Why would he be there if they were like set on why would they be there if they were set on autonomous? I don't think that's going to happen. I think it's going to be with crew. I mean, they might be able to use a Falcon 9 second stage. NASA is not letting a semi-cryogenic second stage near their satellite, near Hubble. No, that's not happening. The trunk solution sounds like a good idea. Yep. Crew Dragon can use the Draco nests on the sides to boost. It can use the Draco nests on the sides to boost in case of bulkhead ring failure. Same like what Dragon 1 used to do. Also, if you add anything to Dragon's trunk, would you compromise the abort system and the Super Draco capability? They talked about this when they refused to carry science cargo payload in the trunk. I don't think it would compromise abort capability. What I think is that NASA and SpaceX don't know if it will compromise or abort capability. Yeah, they don't know. It's not what you know, it's what you can prove. And if there's an issue with trunk payloads on Crew Dragons, then stick the boost package in a cargo Dragon and send it up in a separate Dragon. I mean, I guess. Now, that's architecture with Dragon. I don't think they're going to use a Dragon XL. I think literally the easiest way is to put an adapter to dock to Hubble in the trunk of Dragon. Literally back Dragon up to Hubble, attach to it, no EVA required, and then boost it and then leave. And then leave that adapter on the trunk that has the NDS, an updated NDS docking port, leave that on Hubble, and then just frick off, right? Now, fellas, if you're going to, here's the thing. I told you guys, the shuttle automatically docked to most, or not automatically. It did not automatically dock to anything. It is all manual. Hubble has no docking system on it. There's no docking system on that thing. There's a latching and effector port for the robotic arm, and then there's the grapple point on the bottom. That's it. That's all there is. A manual docking is required. Once again, the manual docking. So what do we know about Dragon? Well, we know that Dragon doesn't have it doesn't have a relative docking system. Dragon is capable of autonomously docking to things, but it does need a receiver on the docking port. It's a two-way radio, not a one-way radio, right? It is not an inertial relative navigation system. So what is, like I said, what does that mean in plain English? Dragon needs the Dragon Eye on ISS. It uses a LiDAR system and it needs a locator beacon to find the docking port. Simple as that. We know that from the ISS. Now, that is not to say that SpaceX couldn't come up with an optical reference system for Dragon. In fact, I'm pretty sure they're exploring it. There's another Elon Musk company that's really good with relative optical navigation systems, but they use them in cars instead. So I know SpaceX is thinking about this right now. I know they're thinking about it. How are you going to dock to it? Even if you could do that whole Dragon trunk thing, how are you going to dock to it? Right? How are you going to do that? It's going to have to be a manual docking, and you're going to need people there because Dragon can't do it by itself. It would not be able to autonomously dock to it. Not many things could. I'll tell you one thing that I know could, actually, to be 100% honest with you, Starliner could do it. If they program Starliner's computers to visually see that NDS docking port on the bottom of the grapple fixture on the bottom of Hubble, if they show it pictures of it and they show what it's supposed to look like, Starliner will use its optical relative navigation system and it will find it and it'll do it automatically. That's one of the things that Starliner has up on Dragon, if you ask me right now. So what's the difference? We'll get into relative navigation systems here. What does that mean? What does that mean? So with a non-relative navigation system, you have a locator beacon on the docking port, and the capsule will look for the locator beacon, and then it'll dock relative to that. An optical relative navigation system literally means that it has cameras on it. Like Starliner has a bunch of cameras on it. It has cameras. And the cameras are looking for a picture of what the computer is programmed to find. So basically with Starliner, when it docked to the ISS on the OFT-2 mission, Boeing programmed its computers and they uploaded a bunch of pictures of the ISS into Starliner's computer. And Starliner's computer, they got it near the ISS and they said, okay, go look for the docking port. And Starliner's computer basically flipped through all the pages of all the pictures of the ISS and said, its computers looked at all these pictures, and then it looked at the camera, and then it looked at the pictures, and it looked at the camera again and said, oh, there's the docking port, and it found it automatically and docked to it. An optical relative navigation system is basically a computer doing what a human would do with these cameras right here. As Das says, the old Mark I eyeball. If you were manually docking to a station, what would you do? You'd look out the window. Okay, the docking port's there. All right, I got to move. Okay, the docking port's there. We got to move a little bit more. That is what an optical navigation system does. It does it automatically, though. It's just looking. The cameras are literally looking for things. Tesla's autopilot does that. So, Dragon doesn't have that as far as I know. Could be wrong. I don't know. And because it doesn't have that, a manual docking is needed, which is once again why I think Rook was there in the first place. I think that's what they're doing. That makes the most sense. Now, that's kind of all a Dragon. The next thing, dudes. What about Starship? Jen said that everything was on the table. How would Starship do this? You basically build out a shuttle's payload bay inside of Starship with all the right grapple points and a robotic arm. If the payload bay is big enough, you just build the shuttle's payload bay inside of a Starship. It'll fit. It'll absolutely fit. It maybe not on the long axis, but it'll be close. It'll be good enough to get Hubble back, right? So that's honestly, if they were going to do something like this with Starship, that's what I think they would do. I think they would basically just they would just use all the engineered systems that NASA has from the shuttle payload bay, because Hubble is designed to accept those. And literally put a robotic arm in Starship and then send it. There's tons of documentation out there about how the latching end effector works. The robotic kinematics that were engineered by the Canadian Space Agency, that's all public domain. I mean, not that NASA wouldn't give SpaceX if they thought they could do it. They wouldn't give them the information. It'll fit. I made an animation. Or grab it and drag it to the ISS and repair it there. The orbital inclination is too different, GLaDOS. Yeah, that won't work. You're talking about a 25 plus degree on-orbit plane change in low Earth orbit. That probably is going to cost you about 10,000 meters a second delta V. Starship does not have that unless they refueled it. But I don't think that refueling with the Hubble on board, especially since it's an unproven thing right now, is NASA probably wrote that one off. They don't want. It's the same reason why they don't want a fuel tank depot attached to the ISS. It's a little dangerous for an unproven technology. You'd want to do that away from the ISS and then prove that it works, and then maybe. But how do you get the astronauts there to put Hubble inside Starship? Starship with a robotic arm. Literally take the shuttle's payload bay and make the shuttle's payload bay inside of Starship. And then put a crew port at the front. Or like put a flight deck like the space shuttle up at the front, up in the nose cone of Starship. It'd be near the header tank, but yeah, plenty of room to do that. Literally make a Starship space shuttle. That's what I'm saying. That would be my idea. Because all that technology already exists. What happened to NASA not allowing cryofuels close to Hubble? There is a additional... Alex, yeah, you missed the context of what I was saying. They wouldn't allow Falcon 9 second stage near there because it doesn't have any it has an aft RCS. There's no RPOD reaction control systems on that second stage. You have a stage that can literally just pitch, yaw, and roll, and that's it. There's no translational controls. Now, I guess you could modify one to have that so it could work correctly, maybe, but that's if you're gonna modify a second stage to be able to perform RPOD. Well, SpaceX is designing a second stage with that capability built into it right now, and NASA's paying them money to figure that one out. See what I mean? See the difference? It's like Starship, that part of Starship hasn't been invented yet or is in its infancy, so you can, in your feasibility study, you can tailor that capability to this mission instead of trying to retrofit something old. Which is ironic, I know, because I just said put the space shuttle's payload bay literally inside of Starship, but if we were gonna service the Hubble Space Telescope with Starship, I'd do it exactly like the shuttle did, because that's what the satellite's designed to do. On top of the bringing things down, how safe would landing be for cargo and people? Huh? What do you mean, Snip? I would assume that, I mean, Snip, let me put it to you like this. They're not gonna evaluate and execute a mission that involves Starship going and getting Hubble, putting it inside of its payload bay, bringing it back down, and then not worry about the landing part with people and crew on board. You know, they're not going to do that. That's like making dinner, right? And all your food's ready to go, right? And you put all the food out on the table and you forgot your forks. It's not happening that way. You forgot to buy forks. Oh, I don't have any forks. Fork you. Right? That's what I'm trying to say. No, I mean, how safe would it be? I don't know, but you can be dang sure that they would take that into account when they do this feasibility study. Absolutely. Did you see that Hurricane Ian is doing exactly what you said yesterday? Picked up pace and heading for South Carolina. Yeah, that's not a revelation from me, Alleviate. I was just basically saying what most of the weather stations were saying. How about Shuttle 2.0, but a bit smaller? I honestly think, Sun Temple, that Shuttle 2.0 is a death trap. Like, literally less safe than the actual space shuttle. Yeah. There's a reason why they didn't make that. Yeah, I think that Shuttle 2.0 is a death trap. You're taking an already complicated thing like the space shuttle, and you're adding more things that can go wrong in the name of safety. That's not safety. That's dumb. Yeah, that's dumb. That's not smart. I don't think that's a good idea. You're adding a bunch of safety systems in for dude, look at this thing. You're taking all the simplicity of the original shuttle's design and you're adding all these things to make an already complicated vehicle more complicated in the name of safety. I'm not going to say it would never work, right? It could work, but also, this is nuts. Why would you do this? Yeah, very nice, Forge, yeah. And now Bowman is out with a concussion. Interesting. This is an already complicated system, and now you're adding an ejectable crew tank. So you're designing two vehicles here. Yeah. Yeah, no. There is one thing that I do agree with. If I was going to do a shuttle 2.0, it wouldn't have the big vertical stabilizer. It would have these. This is better. The shuttle would be much more controllable in supersonic and subsonic speeds, even in hypersonics with these. But also, actually, now that I'm really looking at that, that would cause some problems with hypersonics. And it kind of defeats the point of the armpit wing in the first place, but... Yeah, dude, I think this is a death trap. And you're taking SRBs, which we have 30 years of research and development and technological maturity. We paid for that technological maturity in blood. And you're replacing them with a 4-engine liquid fuel booster, which is like 30-fold more complicated. So you're taking all the safest and most proven parts of the shuttle and you're changing them. That's a death trap right there. I will say it once, I'll say it again. That is a death trap. That thing would kill people more than the regular shuttle would. What engines are on those boosters? The engines. Yeah, really good engines. I don't know. I have no idea. Those motors don't exist. So I will tell you this right now. These things need to produce, the boosters in order to rival the SRBs need to be able to produce 12,000 kilonewtons of thrust. So that means that each one of these things would be like the size of a Merlin 1D and would produce as much thrust as Raptor. It would need to. Actually, it would need to be more. It would need to be 3,000 kilonewtons of thrust. So maybe those are like closed cycle RS-68s or something. Who knows? They don't really say what these engines are. And I know it's not an RD-170, Alex, because these things have hydrogen tanks in them. Like I said, yeah, hydrogen. You guys saw how much of a pain in the butt hydrogen is with the SLS launch attempts the other day. Why would you take the shuttle and make it more complicated? They're a proposed tri-propellant booster with LH2, RP1, and LH2, RP1, and liquid oxygen. Oh, okay. So on top of having the most complicated rocket engines, save like Raptor and BE4 from the last 40 years, right? And then adding a tri-propellant engine, making it more complicated, like a 100,000-fold difficulty over an SRB. Okay. Yeah. Yeah. Remind me why this would be safer again? Anyone? Why not make the external tank bigger with engines below since this is not safe already? The shuttle is safe, guys. You know why it's safe? We used it, even though it killed people. It's pretty damn safe. Come on, EJ, think of the specific impulse gains. Now, with that being said, would I want to see a shuttle with boosters that have, well, let's see, how many Raptors would need to be in the booster? They need 12,000 kilonewtons of thrust with throttle ability because the SRBs have that tail off, so they need to throttle down engines over time. Raptors produce 2,400 kilonewtons of thrust. Let me just do some quick maths. Yeah, it would need 5 Raptors in each stage. Yeah. Yeah, the dice configuration. So, like that. That would work. Excuse me, not RP1, but CH4. What the... Isn't this a real thing? Is this a real thing? NASA won't do it. They considered it in the late 80s and did trade studies, which is why you have this cool isometric drawings of it, Jackal. But they rejected it. You know why they rejected it? Not because they didn't have the money, because it's a death trap. It's too complicated. It's way too complicated. It completely defeats all the advantages of using a shuttle. You want to build something like that, just build a regular rocket. Just build capsules. Just go back to using capsules. Now, fellas, you've always been a fan of this kind of shuttle concept. Guys, check your links before you paste them, please. For the love of God. I don't even know what you're trying to link to me, Pigzig. Sorry, man. You were always a fan more of this type of shuttle. That's more feasible than Shuttle 2, I'll tell you that right now. Here's a link. Oh. Oh, I like that. Oh, why'd you link that, Panda Man? What is this? I gotta read about it. How much do you know about 1972 F100 carbs? Carburetor's a carburetor, Dot. It's probably a 72 F100. So it's either got a 300 inline 6 in it or a 5 liter. 302. So it's got a 300 or a 302. It might have a 351 Cleveland in it. I'd highly doubt it in an F100 though. So it's probably got an Autolite 2100 in it. Or not an Autolite, a Motorcraft 2100. 2-barrel or 4-barrel? 2-barrel? Okay. What do you want to know? Or we cut the shuttle in half with the MPS systems on the bottom of the ET and the crew systems on the top of the rocket. Who would do that, Novus? That's dumb. That wouldn't work. You might have hydrogen leaking problems if you do that. Hard to find replacement parts. Yeah. Yeah, it's got that in it. Oh. It's got a 5 liter. It's made to do a 4R70 automatic and an Atlas 2 transfer case. I like the name. Yeah, okay, so Dot, I'd assume if you're asking me about if you're asking me about that Motorcraft 2100, or it's either a 2100 or a 2150. If you're asking me about that, I'd assume you don't want to buy another carburetor. Okay, so the rarest is right. The best solution here, if you can't find parts, is to just go buy an Edelbrock Performer intake manifold and a Holley 4-barrel and put it on there and be done with it. It does not take much to do that. You just need to change the fuel line fitting, unbolt the old intake manifold, take the cast iron one off, put the new one on, attach all the vacuum tubes, kind of part for part. It pretty much plugs in. It's plug and play. Yeah, Bill, I don't know why there's a 4R70 behind it. I wouldn't have done that. I would have put a ZF5 behind it. But that's just me. It's a 6-digit price tag. Yeah, I'll just do that myself. That would be an excellent paint scheme for the F100 in the other room. I do like that. I do like that paint scheme. Yeah, that's really nice. I love the Steely. The Steely tires are sweet. A 250 with an 8.8 in the back? Holy Batman, this is another proposal from 1981 or 1982. Yeah, anyway, we were talking about shuttle. This thing... I'm not saying that that couldn't work. Anything is possible. But also, that would take years to get that right. Even if SpaceX attempted something like that. I honestly think that full flow stage combustion cycle is easier than trying to do that. Why are we, why are you complicating all the things that made the shuttle good? Everything it has going for it. And you make all those things more complicated. Yeah, no, see, Jackal, now we're talking. Now we're talking. You want... Oh. Oh. I love it, and I want it. I want it. I want that. I want that. They should do that. Oh, why? I don't know, man. I wouldn't put regular Starship on top of this. What I would put is HLS on top of this. Yeah. Could that work? Starship's way too heavy. Even the HLS is too heavy. But if you think about it, guys, right? You launch HLS with that thing, you don't need any refueling. You don't need to refuel it. There's no on-orbit refueling. If you put a lunar starship, if you could put a lunar starship on top of SLS, no refueling. SLS could get that thing into orbit with almost a full tank of gas. Yep. Tank of gas, fuel. But HLS is well beyond the core stage can't take that. It can't take that compression load. It's too heavy. Why not just scale up Dream Chaser in size by 8 times and stick it on top of Super Heavy? Aerodynamics don't scale linearly, Darius. Yeah. The only thing that changes that image are the SRBs and switch to 4 Falcon 9s. Yeah. More complication. What about the other way around? Put an EUS and Orion on top of a super heavy booster? That would be nice, Aqualex. If I was going to do that, I would take a super heavy SN5, then EUS, then USA, then Orion. Yeah, I would put SN5 on top of there. Yeah, the EUS does not have the TWR on top of super heavy. No way. Super heavy does not fly for very long. It's designed, super heavy is designed to achieve a higher staging velocity at a lower altitude. And that's why it's not doing supersonic retropropulsion, because it doesn't need to. It doesn't fly nearly as high or as far as Falcon 9 does. And that's part of the reason why they have yeet amount of engines on the bottom, so they could achieve stuff like that. Yeah, if we were going to do something like that, we would need super heavy, and then you'd need something like SN5, so basically just an upper stage, a regular like Starship-derived upper stage, and then the EUS on top of that. And then put the Universal Stage Adapter and then Orion on top of that. That would be money. That would be an insane booster. Close to the S1C burn time. Convergent design alpha, you even see it at the super heavy launch vehicle level, even with completely dissimilar vehicles. Like I said, it's the same reason why all cars have 4 wheels. There's a really good reason why, because they tried 3 wheels once in England in the 70s and it didn't work. It didn't work well, let me put it that way. It did work. And then they turned it into a space shuttle. Now make this in KSP, MADV. Oh. Super heavy OLV. Yep. What about Delta IV Heavy center core in a second stage, but with shuttle boosters? I mean, Creeper, you basically just described direct. Pigeon, my beloved. Is it easier to human rate a booster than an upper stage? Launch vehicles are human rated, not necessarily stages, Bill. What is this, fortunately? Why in the name of heck why would you replace this? Replace an SRB with that? You know, guys, people can say whatever they want. You can say whatever you want about solid rocket boosters. Oh, solid rocket boosters are bad. They're death traps. They're death traps. Solid rocket boosters have moved more people into space than any other rocket engine, i.e. lifters with solid rocket boosters on them. So tell me again how it's not safe. Zast, you have 2 space questions. Okay. Reusable booster. SRBs are refurbishable. Super Heavy just put starships high enough for all of its engines to be effective. Yeah, exactly, Alpha. Yeah, that. It's like Starship and Super Heavy will fly in a very similar profile, believe it or not, to like Ariane 5. Yeah, it'll be very similar to that. The SRBs are gonna get it up there, and then the core stage is gonna burn. And when the core stage burns, it goes down a little bit, believe it or not, and then it circularizes right at the correct altitude. But yeah, the SRBs will actually shoot it higher than the desired parking orbit. That does happen. Happens with Ariane 5 all the time. Actually, you know what does that too? The space shuttle. Yeah, that thing. That thing does that for the same exact reasons. SRBs are also capable of being shut down. Yep. You could, Aqualex. Yeah, there's ways to do it. Stealth landing boosters. Yeah. Yeah. How much better would a solar panel work in space? They work way better in space, Sass. There's no atmosphere in the way between you and the sun. Spoiler alert, it's a little hotter up there than it is down here. Hotter, it's not really correlative to temperature. It's more about mass being in the way. Gas diffuses light, right? You ever been on the road on the hot days, Sass? You look down the road during a hot day, you see the heat coming off. Heat coming off the road, it squiggles the light. Gas diffuses light. So solar panels aren't as effective down here as they are up in space because there's an atmosphere in the way. Ah, yes, famously reliable from the start, Ariane 5. Screw you, atmosphere. I, for one, welcome our atmospheric overlords. That's more changes in index of refraction caused by variations in temperature. Yes. You're a refraction, Dinkelberg. When you have time, you should see the new NSF vid. Impressive stuff. Okay. Yeah, cool. I suppose we'll start space news from there. But yeah, the Polaris Dawn missions are looking good, and NASA and SpaceX are discussing feasibility studies for Dragon or another potential SpaceX vehicle to be boosting and or servicing the Hubble Space Telescope, that's actually really cool. I'm not going to lie to you. That's really freaking cool news. Also, that's very nice. Yes, the F-250 would look very nice in this color scheme. Yeah, I actually really like it. This is a throwback to the Highboy color scheme. So, if you type in Ford Highboy, Panda Man, this is for you, by the way. If you type, it's a throwback to the Highboy color scheme. Ford in the 70s made a truck, made their F-Series trucks come with what's called a Highboy trim, and they painted them in two-tone because old school. Yeah. Spoiler alert. They still do it. Yeah. Yeah, it's a highboy throwback. That's really freaking cool. Some of them. So the other interesting thing about the factory is that Ford did it a couple of times. If I'm recalling right, this could have been something else. Ford did it a couple of times, and then they said, "Yeah, don't worry about it." And then the dealerships started modifying the cars coming from the factory to look like highboys. The dealerships started doing this paint scheme. They just ordered a white truck, and then they painted it two-tone red at the dealership. I know that the highboys nowadays do not come from the factory like that. It starts as a fleet white F-250, and then they paint the two-tone on it at the dealership if it has a body shop. But yeah, highboys, really, really cool. Oh. What? What, Buck? Wait, Space News is just starting now. It started at 4:30, Bree. I haven't seen that, Gaw. I'll take a look at it. What is this monster truck? That is a Super Duty, a new Super Duty that has a throwback to the highboy trim. It comes with a winch, steel bumper, KC lights, roll bar in the bed, two-tone red, lifted on mud tires. It comes like that from the dealership, which is actually really cool. They're called highboys. Remember how I was talking about this morning about tastefully modifying your truck to make it do more and not modifying your truck in a way that makes it do less? This is modifying your truck in a way to make it do more things. On top of being a good truck, this thing can still haul cargo. You know, you have the cage there, so you have a little bit of an impedance on cargo, but this thing can still haul, and it can go off-road, and it has the clearance to do some heavy-duty off-roading. The winch only adds to the capability, and the KC lights add to the capability as well. I like that. That's cool. Squatting your truck makes it useless. It makes it freaking useless. Anyway. The yellow smileys as well. Those are KC lights, Orion. Yeah. The KC lights come like that. They come with the covers on them, and the covers have the smiley face. It's their logo. They're called daylighters. Yeah, here, take a look. Those aren't smiley faces. It's their logo. He's doing the Lord's work, Coltec. That's right. That freaking Suburban that they had. The hell is that predominant? Yeah, that's their logo. The logo's supposed to look like a smiley face. You don't remember? You do. Oh, yeah. I have a question. Do you think that that's appropriate for the stream right now? You don't think this? You don't think you don't think that this is going to maybe violate one or two stream rules, man? Don't get me wrong, it's funny, but also like, oh gosh, please, dude, I don't need that right now. I don't need that right now, my dude. Just look at the nice smiley face. Look at the nice smiley face. Look at it. Isn't that cool? Isn't that neat? That's neat. My bad, dude. Smiley faces. It's all good, man. All good. It's like sometimes, dude, when I get link stuff like cold turkey like that, I have to, because I'm having like 4 or 5 conversations with people. I have to. I wonder like if it's in context. So, my brain went potato for a second because I thought that was pertinent to discussion. I got really confused, dude. I got really confused there for a second. That's kind of funny. I was like, what is the rocket plane? Yeah, that's all good, dude. Don't worry about it. Check out Gau's link. I'll get my code. No, come back. Come back. No, it's fine. It's fine. It's fine. It's fine. It's all good. And I'm not this isn't the it's fine I'm angry at you either. The passive aggressive. The passive aggressive it's fine. It's actually cool. Don't worry about it. Now, it wouldn't be cool if you just you kept posting and be like, "Oh, did you see that you post something I didn't like?" I said, don't do that anymore. Okay, we're done. Done. That's it. It doesn't have to be difficult. Here, watch this.
Limiter is off. Flight test mode is active. Next step is 100 feet. Correct.
Yes. Let's mount some Dysons to the wings.
Altitude is good to cross.
Oh, that's cool. Do canards, does that count? Do those count as canards if they have propulsion on them?
Okay, 400 full off, right turn, heading 340.
Whoa. Bill should have speared pudding on the weather map and said that was the predicted path. Yep.
95 smoothly. Stable, 4, 3, 2, 1. Clear for a steep climb. Stable.
Stand by. Clear to proceed.
Super.
That's how they used to do wind tunnel testing back in the day, Badger. Yeah. They used to do that with cars all the time. Just attach a couple pieces of string to it. You can see where the low pressure is.
Okay. That is good. You can kill some fits if you want it.
Alright, okay. Initiating the turn. 35 degree right.
Correct.
Right turn.
35 degree right turn. Stable. 3, 2, 1. Continue as required.
Looking for heading 200.
Yeah.
Who needs CFD when you got string and tape? Well, it's a lot simpler, Gaw, but also it doesn't give you as high a fidelity simulation.
95. 5 degrees, 5%. Okay. Descent 5 degrees, flight path 5 Stable. 3, 2, 1. Level off and descent to 80 knots. Steep descent.
10 degrees. Descent.
Stable. 3, 2,
1.
1. Can continue to 450 feet.
Can't rotate my camera in KSP anymore, right? Alt tab out and tab back in.
It is good to cross a nautical mile. You can go to 70 knots now.
70, go down.
300 is minimum there. 200 is minimum with your actual speed.
Look at this thing. They have the propulsion systems on their control surfaces.
Discovery, go at throttle up.
Dr. Peter, I'd fall asleep listening to this guy in comms. Yeah.
Coming in. Okay, perfect.
Pietro, gifted a sub to Leoza. Thank you.
Ground speed is 55.
Ground speed is 55. Question.
and descent.
Discovery, go at throttle up.
Pietro! Pietro! 4-month resub. Thanks,
Altitude is good to cross.
I think it's electric STX, I think.
Level off.
You're over the path. Position's good to land.
Product noise activated. Is out.
Whoa.
Limiter is on. Nothing's out. Okay, let's continue with the cooldown.
I don't know if those are electrics or if those are electric or if those are turbos. Okay, got my attention. Lilium, okay. Lilium air jet. Okay, there we go. Electric vertical jet takeoff. It's regional, so the range isn't very far. Is there a difference between electric and turbojet engines? Yeah. Yeah, of course there is. Electric jet engines have no turbine wheel. So, it's an electric jet, not a turbojet. This could seriously disrupt commuter helicopter service. It actually is really freaking cool, dude. But okay, I think it's really neat. I think that is really freaking cool. I have a question. They're comparing it to a high-speed rail. They're comparing it to a car. But God, you literally just said that this could disrupt commuter helicopter service. What does a helicopter do that this thing... What doesn't a helicopter do that this thing does? I'm confused. Less dangerous flight hardware. A helicopter has less moving parts than this thing does, man. That has like 30 electric motors on it. Helicopter has 2 motors on it. And once again, guys, I think it's cool. I'm not bad-mouthing it. I think it's cool. Why would you choose this over a helicopter? It's electric? Okay. So, Wes, at that point, why don't we just make an electric helicopter? It's 2 to 3 times faster. Okay, so... You're paying a lot more for a little bit faster. Am I right? Your smugness level goes up. Yeah, hey, that's... In this day and age.com, that's a reason. And it looks like, yeah, see, the thing is, I kind of can see it. This thing can travel at high altitude, so it can go faster. Right? High-speed forward flight. Helicopter isn't as efficient in forward flight. I mean... Suppose. It's quiet? That thing is not quiet. No. That's the opposite of quiet.
Flight test mode is active. Next.
Then you have to pay a taxi at Uber when it's land. So, like, this is what I mean. We're doing a feasibility study from this. Why would you use this? Now, don't get me wrong. I'm not one to say like, oh, this is the piece of junk that's never going to work, blah, 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 blah. This is cool. I think it's cool. And I think that has a lot of cool potential. Safety? Same reason why they made the Osprey. Is the Osprey safer than a helicopter, Aqualux? This can still fly conventionally. A helicopter has engine trouble. You are landing now wherever you are. I mean, auto rotation exists for a reason. This looks a lot less cumbersome. Yeah, maybe. Note that they flew the right-hand model, aka the smaller scale. That's cool. Feel like I'm watching an episode of Shark Tank. Look, I'm not saying that that's a bad idea. Those things are cool. There's not... But are you really disrupting the market for like a 30% increase? Or 30% decrease in time? Are you really disrupting the market? It's a little more expensive, and then the cost is correlative to the time saved. Like... So at best, you pushed with a helicopter. It's not better than a helicopter. A helicopter's about the same. Potential for emergency services. Yeah, guys, I'll tell you right now, that thing doesn't glide. Yeah. It might be able to glide subsonically for a little... Not subsonically. It might be able to glide for a little while. That thing gets near a runway. It's not... I don't think that can land like an airplane. Also, this will have significantly less maintenance. I already played Cities today, Maiden. Yeah, I played it for 4 hours, dude. Yep. Envy, how you doing? I think some of your questions are answered here in this video. Sure. All right, let's listen. I'm not trying to be a dick. I want to learn. But sometimes you gotta be a dick to learn.
This allowed us to begin designing our aircraft. In 2020...
All right, let's see what we got.
The basic aircraft architecture of wings and canard with distributed propulsion has been a constant since the early days of Lilium. As the design details have evolved, so has our toolset. As well as utilizing commercially available software, several in-house computational tools have also been developed to enable modeling of such things as aircraft and engine aerodynamics, flight control laws, environmental noise, and structural loads, and many more besides. This type of analysis allows us to quickly iterate some of the finer details of our architecture. Computational analysis is even more powerful when calibrated and validated by testing. Some good examples include wind tunnel testing, where our simulations are matched by flight conditions in a closed environment. And of course, real-world flight tests. Our technology demonstrator, Phoenix, which has been flying since 2019, has been about proving out our architecture in real flight conditions. Recently, we also demonstrated transition and flow attachment on the main wing, where lift is generated by the wings rather than the engines. This is a significant step forward. It's the most difficult maneuver that a VTOL aircraft can undertake. Transforming the future of regional air mobility takes more than just innovative technology. You can build something new that flies, but can it be certified? You can build something that can be certified, but can it be built at scale? You can build something at scale, but can it be sold profitably to a real market? So this requires a very sober understanding of the certification process, which is precisely why we've brought on board some of the most proven technical leaders from the aerospace industry, who've delivered aircraft certification programs and therefore understand the rigor of this process deeply. Let me touch on some of Lilium's certification milestones and why they're important.
Alex.
The European Union Aviation Safety Agency, EASA, is a primary certification authority. We're also undertaking a concurrent cross-validation with the FAA. We have participated in several EASA and EUROCAE working groups, which has contributed to the publishing of SC VTOL certification regulations in 2019. This allowed us to begin designing our aircraft. In 2020, we received our certification basis, the CRI A01, from EASA, allowing us to have confidence in the specific requirements that our aircraft would have to meet. In April of this year, we submitted a full set of certification means of compliance proposals, affirming the precise way in which we would demonstrate compliance with the safety standards. Lastly, the DOA, the Design Organisation Approval. We've now completed our second out of a planned 4 DOA audits, meaning that our engineering team is well on the way to being fully qualified by EASA to design and certify an aircraft. An aircraft cannot be certified and launched without strict adherence to this process from the beginning. Otherwise, you only have a prototype.
That's what I wanted to hear. Yeah. Okay. Cool. Yeah. Okay. That's what I mean. You're gonna be a little bit better than a helicopter. You gotta find another way to get around that. They plan to scale up architecture, and they basically, I mean, you don't call it this, but they plan to crew rate these things. Obviously, right? There's seats in it. So, yeah. Okay. I get it. Yeah. It seems like they took that pretty seriously. It's not just like, oh look, we made something VTOL. Ha 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 ha. No, they. Yeah. Okay. I was more or less looking to see if Lilium actually had their head not up their culo. You know what I mean?
Which is why we're excited to say that we've successfully conducted a rigorous preliminary design review process. We've converged on a final design, which we have every confidence safely achieves the performance our launch customers require. It is a package that can be successfully certified and can be profitably built at scale. Let's walk through where we ended up on a few of the most important design details. Let's start with one of our most iconic design features, our electric ducted fan engines. By simply increasing the diameter of the duct fans by a few %, we were able to reduce the number of engines and maintain the total thrust and efficiency required. This then allowed us to achieve a better aerodynamic balance between the main wing and the front canard.
It
also means a lower unit cost and a lower maintenance cost. And with the large diameter fans, we can use better acoustic damping in the jet ducts to minimize noise. With the change to 30 engines, we have kept the ratio of 3 engines to 1 battery pack. Therefore, the number of battery packs reduces from 12 to 10, but is sized to maintain the overall hover power density of approximately 2,500 watts per kilogram, but in a simplified and lighter weight packaging. We also made some subtle changes to our duct design and the fuselage. We've slightly shifted the main wings rearward and upward, and added winglets to the canard, in order to make the whole aircraft behave better and fly more efficiently.
Cool.
This leads to a cruise power density, which is 1/10 of the hover power, and allows us to improve our range. We've added running...
See that right there? That's actually a pretty big deal. So basically, it needs 1/10 of the power to fly in stable flight than it does to VTOL. That ratio is pretty good. That means that also, at the same time means you can go fast. You can go fast with this thing. If your cruise power is 1/10 of your hover power, this thing can go very fast. Yeah, faster than a helicopter. There you go. This is the kind of stuff I'm looking for.
Landing capability, which is important to certification because it increases reserve range to address the jet's ability to deal with real-world scenarios and be able to divert to alternate landing sites and perform a short-running landing.
How about you?
Which gives us the ability to use more cell energy than is otherwise accessible in a normal vertical landing. We also believe that such a capability, while rarely used, will provide additional reassurance to our customers.
Agree.
In terms of operational safety, our 30 engines, large number of flaps, independent battery units, and multiple flight control computers provide us with significant redundancy. We are on track to meet the extreme...
Okay, he sold me. Yeah, that's freaking cool. That's way better than a helicopter. Yeah, no, you sold me. I'm good. It's got a ways to go, dudes. It's Novus, you're right. If they're at PDR, it's got a little ways to go. They need to complete the hard part, which is scaling up. But yeah, no, that's cool. That's really cool, actually. Yeah, I dig it. Yeah, that guy that's talking spent 33 years at Rolls-Royce and was the head of Rolls-Royce's engineering team in Germany. Yeah, okay, yeah, he knows what he's doing. Yep. Paco, 59-month recip. So yeah, you can dead stick a landing with that thing. So it can land like a regular airplane if something goes wrong. And God, I assume that that's what you were alluding to, right? So yeah. Yeah, that's cool. And I bought shares. Yeah, that dude.
Extremely high.
Wicked.
10
That's
to the
really
minus
cool. I
9
like the gantry
safety
crane behind
standards.
him, by the way.
This means the probability of a catastrophic failure is less than or equal to 1 in 1 billion flight hours, as set by EASA for commercial aircraft and for eVTOL. Our battery team has been evaluating dozens of candidate cells over the last several years. We have now picked a very capable cell design, designed by Zen Labs and manufactured by Custom Cells, that we believe provides us with excellent power density as well as energy density
I didn't hear it. Let me...
for commercial aircraft and for eVTOL. Our battery team has been evaluating dozens of candidate cells over the last several years. We have now picked a very capable cell design, designed by Zen Labs and manufactured by Custom Cells, that we believe provides us with excellent power density as well as energy density. The battery is exclusive to Lilium within our target market, and we believe it could be one of the highest performance cells that is practical for eVTOL in existence today. The advantage of the Zen Lab cell is its combination of both superior specific energy
Astral is right, Alex.
and specific power capabilities.
Hang on. One more time.
In existence today. The advantage of the Zen Lab cell is its combination of both superior specific energy and specific power capabilities. When compared to commercially available state-of-the-art cells, the Zen Lab cell surpasses both the specific power capability of the high power cell and the specific energy capability of the high energy cell. It's critical to note that based on these independent test results from Energy Assurance, the cell is able to support a high specific power of 2,500 watts per kilogram, even down to 20% state of charge.
How did you do that? Yeah. How'd you do that? Yeah. It maintains, yeah. Down. Hey, how'd you do that?
Of the high power cell and the specific energy capability of the high energy cell. It's critical to note that based on these independent test results from Energy Assurance, the cell is able to support a high specific power of 2,500 watts per kilogram, even down to 20% state of charge. So, when we tie all these design to support a high
Wow, that's impressive, dude. So, okay. What is this guy talking about? If none of this makes any sense, two things. So the batteries have a lot of power, okay? They 2,500 watts a kilogram is unreal. That's really, really good. But so we're talking about specific energy here. Specific energy is basically the rate that it outputs at, for long story short. So it has 260 watt hours per kilogram net energy density, meaning the plain English way of saying this is that it maintains a high power output for basically all the way down to 20%. And these batteries for the weight are give you about 2,500 watts per kilo. So that's 2,500 watts for 2.2 pounds, which is that's a lot of power for not a lot of mass. Basically these batteries can run at full blast up until about 20%. When you get down to 20% charge, that's when the power will start falling off. That if anybody here has ever had an RC car, You know what I'm talking about. You drive your RC car around at full charge, it goes really, really fast, and then as you drain the battery more and more, it starts to get slower and slower and slower and slower and slower and slower until it stops. This thing stays at full blast until 20% power, and then it'll start going slower and slower and slower and slower, which is 20% charge, which is that's what I mean when I say, how'd you do that? Yeah, specific means per unit mass. Yeah. Yep. So basically, this stays at a really high energy output for majority of the battery charge, and it holds a lot of energy inside of it. The energy density is, I mean, you'd be hard pressed to get this out of like a jet engine, like a fuel tank. You know what I mean? Unless you're a good engineer, use a voltage regulator instead. Yeah. Right. Yeah, the voltage regulator. Yep. Yeah, Alex, I actually know about voltage regulators. My truck has a voltage regulator on it. The 59 does, and so does the 97. They have a voltage regulator because if you rev the engine, the alternator is going to spin faster. This kills the battery. That's why I have a voltage regulator attached to the alternator, because varying power output, the voltage regulator equalizes that power output. Anyway, let's keep listening.
High specific power of 2,500 watts per kilogram, even down to 20% state of charge. So, when we tie all these design elements together, we remain on track to meet our previously stated physical range of approximately 250 kilometers or 155 miles, using a short vertical takeoff and landing at operational empty weight. This equates to a projected operational range of approximately 175 kilometers, assuming a vertical takeoff at maximum takeoff weight and a vertical landing, 45 seconds duration.
So, okay, that's the trade-off. You know, how did they achieve energy density similar to, like hydrocarbons? They did it with an electric vehicle at the behest of range. Yeah, long story short, they did range. The range is a lot shorter. Guys, it's a flying car. It's literally a flying car. Yeah, that's a flying car. Like the Jetsons. That's what that is. That's why these numbers are the numbers in the previous graph are ridiculous. Like that is this energy density and this specific energy is on par with gasoline, but here's the thing. You could just the batteries on this thing are really, really small and can output a high charge for a short period of time. But they're still better than other batteries. But like if you compared this to like if this thing had like jet engines on it, right? Like a hydrocarbon jet engine, these numbers would be over here somewhere if I'm thinking about this right.
Of 2,500 watts per kilogram, even down to 20% state of charge.
Yeah, Matt, right?
So, when we tie all these design elements together, we remain on track to meet our previously stated physical range of approximately 250 kilometers or 155 miles, using a short vertical takeoff and landing at operational empty weight. This equates to a projected operational range of approximately 175 kilometers, assuming a vertical takeoff at maximum takeoff weight and a vertical landing, 45 seconds duration, such that 20% state of charge remains following the landing. It's worth mentioning some important points here, since these calculations are often misinterpreted. We use conservative vertical hover face assumptions in our calculations. This range doesn't account for the additional 20% energy accessible for reserves thanks to the rolling landing, which would be supplemental to these figures. Lilium Ultimate Operating Range will account for these reserves as well as other certification requirements, and will be confirmed between now and our entry into service. We believe we've converged on an optimum final jet architecture that will meet the agreed certification requirements and achieve a projected physical range of approximately 250 kilometers at launch, which is more than enough for our anticipated launch routes. As battery technology and performance improves, we will be able to upgrade the aircraft with newer batteries and offer even longer range to our customers.
The VTOL variant should fly very soon. Zenlabs Energy CEO Sajid Kumar was CTO at now defunct NVIA Systems from 2007 to 2017. Both Kumar and NVIA were accused of misrepresenting NVIA's battery technology to investors and a customer, General Motors, in 2013. GM investing in fake technologies? Making stupid financial decisions? GM? Oh, come on. The automaker canceled his contract with NVIA on the grounds that it was predicated on a number of statements and representations made by NVIA and NVIA's representatives that, in retrospect, and in light of more recent statements by NVIA, appear to have been misleading. Whoops. Having that 30% margin also means you're stressing the battery. You are stressing the battery less at lower charges. Yeah, exactly. Because draining batteries fully, Alex, is really bad for them. You ideally never want to drain it fully. Because, yeah, this kills the battery, right? Yeah, I know. I have a dead car battery in my garage. It's the Coronet's battery, and I didn't have the battery in the Coronet basically all year. And, yeah. It's dead. I think it's dead, Jim. It's very interesting. Interdasting. I heard with lithium batteries, it's really bad for them to be below 5% charge and above 80% charge. Yeah, Buck, if I'm remembering correctly, Tesla does that. 100% charge on a Tesla never is like true 100%. Their 0 to 100% is graded on a scale from like 20% to 80%. Yeah. If I'm understanding that correctly. They do that so the batteries can last longer. Yeah, you don't put the battery through as many. I think it's called the duty cycle with batteries. Do you have a Lambo in your garage? Nah, I have a truck, pickup truck. He said duty. Yeah, the duty cycle, exactly. Night Sun Temple. Is that a Supra? With these, so I mean, honestly, fellas, what can I say? Vertical takeoff, horizontal landing is the way to go. Yeah, that's the right move. That's the right thing to do. Vertical takeoff, horizontal landing. You know, I can think of another vehicle that does that. See, the right idea. What can I say? What can I say? That's the right idea, am I right? Oh, yeah. Look at that thing. I'm not going to, even now, I'm not going to not make up an excuse to look at a picture of Discovery. Like, didn't they do that in the 80s?
Discovery,
they did do that in the 80s. Tabak, tier 1, 90-month resub. A 90-degree flip. How fitting. I'll land now. Okay. You guys will see, and some folks have kind of figured it out. You guys will see just how crazy good the shuttle was at what it does. As we see Starship kind of progress, and you see the challenges in goals and that SpaceX has and the hurdles that they have to overcome, you guys will realize how ridiculous the shuttle actually is. It is a phenomenal piece of equipment, even to this day. 90 months, 7.5 years. Tabak was there the day I got partnered. April 11th, 2015. Yeah, Tabak was here. I remember. Yeah, he's been subbed as long as you could have the option to sub to the stream. He's been subbed. So is Hokie, to be honest. So is Schmugelidorf. And so is Yardnit. And so is a bunch of other people. Oh boy, EJ's gushing about the shuttle again. Just another Friday. And Buck, and Yarg, and Matt, and Yuck.
Discovery,
and Hokie. Did you see the electric plane can generate lift with the wings? If so, that means it can glide. Yeah, it can, Novus. Yeah, it can. Yep. Dude, like, that's such a good idea. You can vertical takeoff out of cities. Like, sorry, it feels like a Friday for me for reasons. Oh, okay. I was going to say I don't want to read too much into that. It's Friday for some people. It's Friday for the Europeans. It's Friday morning, but in Australia, it's Friday after. No, it is Friday morning. Yeah. Anyway, Hokie, thanks for the 5 subs. All right. But yeah, that Lilium is pretty cool. I'm not sure about the CEO with the battery thing, but honestly, fellas, like despite the battery, like that makes sense. There's always a trade-off, dudes. There's always a trade-off here. All right, he shows. So this, like I said, this seemingly is ridiculous. This is rivaling basically what a jet airplane would. These numbers are in line with if this thing had jet engines on it. For like, I'm trying to speak to this in as plain English as I possibly can. These numbers are in line with a jet engine. That is right. But if you try to make a battery work like a jet engine, you're gonna have problems. The problem, not problems, you're gonna have a trade-off. That's your trade-off. Look at the range. This is why we don't just flip to electric vehicles tomorrow. I'm not saying it can't be done. I'm not saying that electric vehicles can't someday get this good. What I'm trying to tell you is that it's not as easy as you think it is. See, 175 kilometer range. My 59 F100 has better range than that. Now, don't get me wrong, it doesn't fly, but you get the idea. Okay, thanks, man. Thanks for being here, dude. You know, like, and that's everybody, dude. How many people did I just rattle off right there that have been watching for 7.5 years? Like, I don't forget about you guys, you know. And yeah, thanks for being with me this whole time. It's been a fun ride, dude. Can you just like look where we're at? You ever think we'd get this far? I have a freaking house because of the stream. That's weird. Your F100 also doesn't cover that distance in an hour. Yeah, trade-offs. I got what Bremo had over the last couple of days. Guys, part of the reason why I've been stopping streams early and stuff is because Bremo's been sick. And, yeah. I have that now. That's good. Yeah, great. Just in time for the marathon stream. No, I'm not stopping. No, we're going to keep going. The trade-off is that you don't exhaust your power source in the atmosphere, so you don't get lighter along the way. I'm wondering, how can this work? Singularity 17, winter size with the 32. No, this is just a cold. I had COVID in June, in late June. Yeah. I'm immune to that for actually till right about now, but this is a cold. I had COVID. These symptoms aren't the same. With COVID, I coughed a lot. Like a lot. It was a lot of coughing, and then you dry heave cough. People who've had COVID know what I'm talking about. It's your body's trying to huck up mucus that isn't there, and you like dry fire cough, and it hurts like hell. It really hurts. This is not that. This is just a cold. I just have nasty post-nasal drip. Honestly, you probably save like a lot of money not having to pay for gas. Yeah, that's true. I did spend enough money to drive the truck across the country, though, Stream Chat. I don't think that offsets commuting, but yeah. So how can this work with magnets, Forge? Oh, that's kind of cool. That's kind of cool, Forge. Basically, it felt like someone took a sledgehammer to your sternum. Yeah. With me, it was particularly bad. Yeah. It was not. But see, like, it was bad, but it was only bad for like a day and a half. And then it was just dry heave coughing after that, which really sucks. How's the weather? It got cold, Dan. Yeah, the last couple of weeks, like the last week and a half, The warm front went away, and the cold front's here now. The damn Canadian air. Yeah. Yeah, dude, it got cold. It got cold here real quick. Like, it went from being like 90 degrees during the day to like 60 degrees during the day in a week. Yeah, Aqualux, yeah, exactly. Mm-hmm. Can you give your thoughts on Project Havoc? Yes, here they are. I don't know what that is. I don't know what it is. I'm sorry. I don't know, Jeff, has it? I must have missed that. Red card. I don't know, Jeff. Oh, I don't know. Same in London? Yeah. Dan, it's those damn Canadians. They keep bringing that air down here. Damn you, Terrence and Phillip. Chris Kamara impression? Oh, I don't know, Jeff. Still 0-0. Bro, that makes me laugh every time. Nah, they ain't even that air ain't even American. What's worse is when we get Canadian rain. It's rain, but it comes down and it's frozen, and then it just stays there. Doesn't seep into the ground, just stays there. It stays above the dirt. Damn Canadian rain. Ugh. Chris, get your fingers out. Get your fingers out. No, I saw him come off the field. I thought they were putting a sub on. That's still funny. Rogue, that's still funny, dude. Don't ask me why I know that, why I know what that is. I don't watch soccer. I know of that, though. Still 0-0. That's still funny, man. Oh, boy. Okay. This is what we want to see, huh? Let's check this out. No, not that one. We need this here. This vidya. Right here. Yeah, we're going all the way to the Firefly rocket, guys. This is the oh. Oh. That's nice. That's nice. That's pretty neat. Where's this video coming from? I will like that. Okay. That's pretty cool. That's brilliant. That's brilliant. You know, that's really nice, and I'm gonna let you finish, but also... Oh, thank you. Don't forget that Canadian rain tastes like an Italian dessert. No, you gotta drink the yellow. Headphone users, this could get loud. Nice, Thomas. There you go. What do you think of this? That's pretty coggers. Yep. Yeah, I like that. That's pretty neat. This is all right. No, that not doing anything for you? What about this one? got another Tory angle? I don't think that's that, but that's pretty cool. You got another one? Another one. Yeah, just let me just. Pink. Oh, there they go. Yeah, right there. Very nice. Very nice. That's that. Yep. Yeah, I really appreciate what you're showing me right now. Really appreciate what you're showing me right now. I mean, also, Tomas, your words, man, not mine. I saw the 361, Thomas. We watched it yesterday. Can I? I love Delta. It's such a good rocket. Oh, look at that thing. That's nice. Oh. Yeah. We need to. Somebody gifitize that, please. Gifitize is your vocab word for the day. Yeah, just. Please gifitize that. Have you watched the Raptor Relay video? That's what I have teed up next. And also, fellas, yeah, also, you see. Thanks, Sabaton, for an experience Denver will not forget, and thanks for teaching real history in the most captivating way I can think of. And thanks for your interest in the thermodynamics of Delta IV Heavy's LH2 chill down cycle and its totally metal ignition fireball. This collab is a surprise, to be sure, but a welcome one. Yeah, that's Tori Bruno with Sabaton. What the hell? Dude, all right, let me put it to you like this. I knew Tori Bruno was a metalhead. I knew he's talked about it before. He says that he loves, he's a huge metal guy. Like, I knew he was a metalhead, but also you think some of them will give Tori some hair? No. The reason why Tori Bruno has the aerodynamic look in the first place, Bandit, is because he's so metal that it's like you ever see Tenacious D in the Pick of Destiny when they're singing Master Exploder and he's like, yeah, and the microphone explodes. Tori Bruno did the metal scream and his hair caught on fire. That's the problem. That's why he doesn't have hair. You know, That's come on, EJ. That's why he doesn't have hair. So, you know, Sabaton's metal, but Tori Bruno is. So, if the guys from Sabaton tried to attempt the Delta 4 heavy metal scream, their hair would immediately burn off. It would be ablative. It's science. It's science. Yeah, see, like we knew Tori Bruno was a metalhead, but also, yeah, that guy's pretty cool. Yeah, exactly, Alex. Yeah, much like how Delta 4, lights itself on fire. It makes sense. It makes sense. It makes sense. I heard Tori Bruno's hair went to teach at SpaceX. Yeah. Yep. That's freaking. This is the collab I didn't really realize that I needed, but also you think he's showing him the Delta footage that we just looked at? He definitely is. He definitely is. Excuse me for a second. I just. That did not mean to blow your mind. But that happens to me all the time. I love this footage. I love it. That's so good. Oh my goodness. That's so good. I love it. I can't stop watching it. I really can't stop watching. The tweet wasn't bullcrap. I'm serious. I shut off the stream and I just watched it over and over last night. I'm like, that's really cool. I like that. Speaking of propulsion, all right, here's the new NSF video. What happened to Tori Bruno's hair? I just told you. He was frontmanning for a metal band, and the metal scream was so... like how rockets have sound suppression systems, all right? There was no sound suppressor. So when Tori Bruno went into the mic, that's not what it sounds like. If I made it sound like it, the whole stream would probably disconnect from, Sonic. But so it reverberated, and that reverberation, caused fire, Yeah, and it burned. It's a blade of hair, and it's gone. It's just gone. It didn't grow back. So the metal it was so metal that his hair fell out. Yeah, his hair fell out. Yeah, that's you can't even hear it. Nice. I clipped the mic. Oh, that's good. That's good. Here, maybe if I turn the threshold down a little bit and then go. Like that? Did that work? Nope, still didn't work. I thought you were joking, but now I believe you. Yep. All right, next thing. Let's see what we got. Iron Spark Tier 2 19-month resub. Keep doing you. Thanks, man. I'll keep doing. Yeah, no, I'm not changed. I'm too stubborn to change, man. Good for lots of things. See, good and bad. Cuts instantly. Amazing. It's friction stir welded and then ablated. Yep. All right, so NASA Spaceflight released a new video, and SpaceX tests Raptor engine rapid relight. SpaceX tests Raptor engine rapid relight. Raptor engine rapid relight. Rapid engine rapid relight. Damn it! Raptor engine rapid relight. Raptor engine rapid relight. Raptor engine rapid relight. She sells seashells by the seashore. Unique New York, unique New York, unique New York, unique New York. Raptor engine rapid relay. Piper picked a pecker, picked a pecker. Damn it! That's one on the test stance, Berkeley. Ooh. Whoa, 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 whoa. Whoa, wait a minute. Whoa! Whoa! What the? What? No. Surely. Whoa. Okay, guys, rocket engines in real life are not like KSP. You can't just throttle them up and throttle them down and turn them on and turn them off and turn them on and turn them off and turn them on and turn them off and turn them on and turn. That doesn't work like that. That breaks rocket engines really easily. With that being said, what the frick? That thing should blow up. Unbelievable. Electric turbo pump? No. No, it's staged. It's Raptor. It's a staged combustion cycle. There's gas generators. How is that even possible? How do you do that? How did you do that? Okay, all right. A little bit of a visualization as to why this is a pain in the butt. Rocket engines have a lot of plumbing. Propellants are being moved around. A lot of commodities are moving really fast. Amongst other things, like the turbine impellers need to start and stop, right? The pumps that pump the gas, that the gas generator turns the pump feeds into the gas generator, etc. That all needs a second to start and stop, right? It spools down. Now you can see the pump spool down when Raptor coughs up that big fireball the first time around, right? And they stop. They seem to stop the impellers really quickly, or found a way to do it. I don't know if they're using back pressure or something to stop it, but yeah, it stops pretty damn fast. But here's the thing. So when you start and stop a rocket engine, right? Say you have a spigot on the side of your house, a water line, so something that goes to like a sprinkler, right? And you turn on the hose the first time. What happens? The water takes a second, and then the sprinkler turns on, right? Now, if you close it again, and then you open it again, it won't take as long for the sprinkler to start working again, but it's not going to go right to full blast. Which means that the lines, the plumbing to the Raptors were never depressed, which... yeah, that... You see what I'm talking about? It puts a lot of strain. Puts a lot of strain on things, starting and stopping like that. You hear the kind of strain a lot if you live in an older house and you turn the water off and on, and you turn it off and the pipe goes like that. It goes makes that weird hammering noise. Literally that happens inside, like starting and stopping. Like you're not going to have the pressure high like on a sprinkler, right? So you turn the sprinker's going to take a second to turn back on, right? SpaceX they have to fix that problem because you don't want to get cavitation inside of the engine, right? So they found a way to keep the lines pressurized, so it's working more like a shower. And when you start and stop it like that, it strains the entire system. The fact that Raptor can do that and not just blow up the entire test stand is actually pretty frigging impressive. I don't know of any other rocket engine that is a staged combustion cycle or any type of gas generator fluid impeller delivery system that can do stuff like that, except maybe if it's hypergalls. So they found a way to water hammer without killing stuff at like 6,000 psi. Yeah, Firefly's getting ready per Tim. Very good, very good. On a high pressure line, if you cut the flow, it creates a peak and the pressure wave goes all the way back on the line. That's what I mean. It's you're hydraulic hammering your rocket engine doing that. Because it can't be like the sprinkler, right? That's the problem with why you don't want to restart a rocket engine like right off the bat, because you have to repress the lines, and then you have to thermally condition everything, and then you get ready to fire again, right? Like this thing can just flip the switch on and off. That's not a thing with rocket engines, at least until now. Do we know how quickly a Merlin can reignite? It takes a second, Admiral. Merlin engine, I don't think Merlins can do that. So what do they plan on using the ability to start and stop the motor for? No, I don't, Predominant, no. That? In case a motor fails or whatever, they can turn the other engines back on. They probably keep them pressed, so it probably making landing safer, basically. See last close. Okay. I did hear that SpaceX fires 3 engines for the landing burn, and it shuts off one of them to land on 2 in the case if one of the latter 2s fails, the third one will restart immediately. Yeah, there you go. Yeah. Yep. The other way to tell that they didn't depress the lines immediately, a lot of rocket engines depress the lines immediately and they start shooting helium through the lines, or nitrogen. They start shooting helium and you see them, to basically avoid making it burp like that. You see it burp out the methane. It burnt out a methane-rich mixture right there. Rocket engines, Merlins do this. Merlin 1D, Merlin 1D VAC. All do this. The shuttle engines do this. They purge out the plumbing with inert gas to make it not cough like that. So you don't get, the thing is that when you shut a rocket engine off, right, it's going to take a second for everything to depress, and you're going to get additional fuel and oxidizer, the stuff that was left in the lines when you shut the taps off. That will drain out of the system. That's what that is. It's draining. Well, not necessarily. That's not necessarily draining out of the system, but in this particular case, but that does happen, and so they shoot helium through it to get everything out, and because it's mixed with inert gas, it won't combust. SpaceX had problems with that with the Falcon 1, where they shut down the first stage and they didn't purge the engines, and the first stage had a little bit of residual thrust. It burped and came back and hit the second stage on Falcon 1. Very interesting footage. Now, in this particular case, this is just coughing up all... this might be the extra methane and oxygen that get put in there from, I don't know, maybe they repress the lines for flight when they shut the engine down or something. I don't know. Oh, thanks, Chief. There you go. But yeah, something to notice is that there's no helium purge here. It just, see how the methane just kind of goes everywhere and lights everything else on fire? Oh my goodness. Dude, that should blow up. You tried to do that with any other rocket engine, it'll explode. There's more to this. Okay. I bet they have a recirculation system. Something is on there repressing the lines extremely quickly. You can see the tank vent between firings. How did they repress the lines that quickly? How does that even happen? Oh, thanks for giftizing it, fellas. I appreciate it. Chief, I got one from you, and I got from you. I'll see which one I want. How do they repress it so fast? And more importantly, even if you did figure out a way to do that, how are they going to do it on Starship? Man. Electric turbo pump? This is Raptor. Astral, it's Raptor. This is stage combustion cycle. You still have turbines spinning. Turbo pump the lines. What? Idea, there's two taps going at the same time. One closes at the turbine to stop the flow, and the other opens further up into a chamber to hold the pressure like an air tank. So you're saying this rocket engine that's moving liquid commodities around works like an air tank moving gaseous commodities around. Okay. You're a turbo pump. Ouch. Very short lines that pump on top of the chamber with basically no line language. Well, I mean, why would you test this if it only works on the test stand, Hellfish? Starship has to be able to do this with that downcomer, which is crazy, dude. That's really impressive. Some type of anti-lag system. If that's what you're describing, Tessa, what Luizo said is a better way to do it. They literally have anti-lag on a rocket engine. Like, could they somehow plumbed it back into the tank for autogenous pressurization? Yeah, I mean, we know there's a gas tap off. They could be using the autogenous pressurization to do that. But see, here's the thing, Darius. If you're going to use autogenous pressurization to immediately repress the lines like that, you're going to get geysering. Remember, you're flowing cryogenic propellants around and you just stop the engine, which means you're going to get some propellants evaporating, just like with SLS. It's methane. Methane is really close to hydrogen. It's very similar, right? It's a little bit more stable because carbon makes the carbon atom makes it stable, right? So like liquid hydrogen is LH2, liquid 2 hydrogen. Liquid methane is LCH4. Liquid carbon hydrogen 4. So you're still, dude, that's still a lot of hydrogen, right? You could anti-geyser it and you could blow a line, which makes this even more impressive because this isn't using like hypergalls or something. This is fully cryogenic methylox stage combustion cycle. Unbelievable. That's damn impressive, dude. Did you see the vent out the side of the stand right frame on shutdown? Yeah, there you go. Yeah. Do you think they do an engine chill between firings, or does it stay cool enough? Phil, I don't know. I don't know. Like, guys, this is getting out of my wheelhouse. I don't know. I don't know. I know that they're keeping the lines pressurized. The engine wouldn't be able to restart like that. Right? How does it... I need to see something again. Hold on. I need to watch this in slow motion. Okay, so on startup, there's a little, they flood the engine, so that's the turbine starting up, and you see a little bit of methane out here. There's a little bit of gaseous, atomized liquid methane and liquid oxygen. You can just barely see it right there. And you guys ever see like, you ever see the video of people that have like methane gas in a glass jar, and then they light it, and the flames kind of go down for a second, and then the whole thing goes whoosh, like that? That's what Booster 7 did during that spin start test the other day. That happens to a little extent every time this thing fires. You can definitely see it. Watch it again. Ready? So you see a little puff of gas come out of here, and then boom, the thing starts right up. See it? It does that. So wait a minute. The U.S. Space Force wants the Blue Origin Rocket Lab SpaceX win $87.5 million in awards from the Space Force's Space Systems Command for new launch vehicle technology. This was in 2021 for fast start capability. This project projects rapid throttling and restart testing. Yep. So, all right, fellas, this thing coughed a little bit of methane up right at the beginning. That's not what a Raptor start looks like, dude. So those lines were already pressed, which is unbelievable. I don't know how they're... If you... Okay. All right. This is getting... Guys, this is very, very quickly getting way out of my wheelhouse. I'm not going to lie to you. So check this out. Let's watch Booster 7, the 7-engine static fire from the other day. Do you see the same thing going on here? You see what I'm talking about? It's a much longer stream of atomized methane coming out of here before the thing goes off. That stream is when the turbines are spinning up. Right? I want to point out that didn't happen here. See, it was like a cough, and then just immediately full thrust. Honestly, I have to ask Rocket Guy. It might just be that we're far away, so we can't see it, but that Raptor has a pump directly on top of the chamber that would provide super fast response. Yeah, but you still have to spin the freaking power heads up to 60,000 RPM, Hellfish. They have to spool. You have to spool the pumps to be able to rapidly restart something like this. How do they do that with... How do you do that? Yeah, Dragon, right? Guys, they must overpress the lines. They have to. That's no more for the test end going off of previous firing tests. Okay. Let me see if the restart has it, Thomas. Yeah, see? They did not gas purge the engine. That's why you got that big fireball at the end. What the hell? I need to watch this in slow motion. Give me 1 second. Jeez, I didn't even see it. It was so fast. Yep. Okay. Six frames. So 6 frames on the second start from nothing to full to up to full thrust. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. About 20. Let's say about 20. Okay, 20 frames on that start. That's why this second restart is nuts, dude, because let's do it again. I want to see it one more time. Okay, so at first sight, all right, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Half the time for that restart. I don't know, Gladys. The hydrostatic turbo pumps, the hydrostatic power heads can spin extremely fast. They're keeping the turbo pumps spinning. I don't know, dude. How? How are they keeping them nitrogen? But that would mean we'd see nitrogen come out the bottom before it ignited. They don't stop the turbines. They let them free spin and use the momentum to restart. Then your lines would depressurize, Hellfish, or else it would just pump more fuel. Could I get the raw footage from DOS? Maybe. See you last. But to be able to press the tanks just enough to get everything moving in a pressure-fed engine to start, that's how, I mean, yeah, I suppose. Letting the pumps coast. Yeah, but if you do that, fellas, that means you got fuel out of the line, because if there was fuel still in the line, it would just slosh it around and it would come out the bottom, right? But you shut the engine off. Remember, garden hose. We're talking about hydraulics here. Cryogenic hydraulics. Nonetheless, you can't, the second you start trying to compressorize, the second you start to compress the methane in the lines and overpressurize it, you're going to get gas, especially with methane. So either they found a way to just depress and evac the entire engine real quick, right? Which doesn't make sense because then the second start would be even quicker. Recombobulate. Are we saying the turbo pumps have brakes? The Gardner's analogy, not turning the water off on the tappet at the sprayer. Yeah, Tessa, exactly. But the thing is that this is stage combustion. So turning it off at the sprayer, so to speak, right, is... How are you going to do that if you have a fuel pump behind you? How are you going to do that with a stage combustion? How is that possible? I'm impressed, dude. That's really, this is beyond me, dude. I don't know. I'm not saying it's impossible. Like, obviously it's not impossible because it's happening right there. But man, is that impressive. Yeah, 2020 maybe. But so you saying if they close they close the valves to the fuel tank and then you get a residual fireball, the unpressed fuel and liquid oxidizer, just a thought. But yeah, 2020, that doesn't explain the fast restart though. If they evac the system by having that fireball cough up at the end, right? How did they repressurize and thermally condition the engine that quickly without getting gases flowing through it? This is what I mean, man. You're going to overpressurize the line. Like, you're going to hydraulic hammer the freaking rocket engine. Like, that's... How? Dude, that's impressive, man. Yeah, Bill, it's just damn impressive. Some kind of solenoid valve above the pump? Yeah, yes, man. then how can they thermally condition the engine in 9 seconds after a shutdown? And how can they start the preburner? It's a gas-gas interaction in the, yeah. Yeah, I don't know. An anti-lag system, maybe? Like, I don't know. The closest thing I can think of is just it's an anti-lag. It doesn't. I don't know. Pre-valves, maybe. The pre-valves is the only thing I can think of. That's the only thing that makes sense. But then again, this is a lot more complicated than just, oh, shut those valves off. I mean, guys, just if you know a little bit about physics, look at these numbers. How do you stop that? How do you stop a pipe that's at 640 bar? How is that possible? I mean, keep in mind these numbers are estimated based on thrust output, but also a big valve. It's gotta be the pre-valves. It's gotta be the pre-valves have to be it. Give the pressure to go somewhere back into the tank. Yeah, test it. Yeah, the pressure somewhere back into the tank usually doesn't end well for rockets. That's what I'm trying to tell you. That usually doesn't end. Booster 7's downcomer crumpled itself. Oh. I wonder if that's correlative. A little while ago, Booster 7 damaged itself on the inside out, and the methane downcomer, which is a pipe that goes through the liquid oxygen tank to get the fuel down to the engines, it imploded. It crunched itself. It looks like if you had like a pipe that was made out of tinfoil that you could crunch, like a soda can, and just crunched it like that. It imploded. Pressure into the tank would burst the pipe, not collapse it. Okay, Novus. All right. This is where my physics, your physics, I will defer to your physics knowledge level. If you had a rapid depressurization of a pipe, if you had a rapid depress because it was at high pressure, would it implode like that? If it popped somewhere else, would it crunch? Honest question. Yeah, like a turbo wastegate. Yeah. Yeah, yeah. Keep in mind that the CH4 downcomer and Super Heavy also acts as the CH4 header tank. Yeah. Yeah, I don't know, Forge, maybe. Yeah, maybe. Dude, yeah, there's got to be like an anti-lag system in here because even with what we're talking about, like if you rapidly cool off a sealed drum, it will implode. Yeah. If it has gas in it, Hellfish. Yeah, guys, yeah, the only thing I can think of is something like a wastegate or a blow-off valve. Keeps the turbine spinning. Or an anti-lag system. They are venting something into the engine. They are venting something out the test stand, right? Like between the firings here, there is gas, pneumatics that are being vented up here like crazy. See? Yeah, it has to be. They have to be using gas somewhere to. My guess is they're. My guess, this is just a guess based off of what we've seen, and you guys kind of steered me in this direction. I'm not going to lie to you. My guess is that they're using the pre-valves. They're using the pre-valves. You keep these lines pressurized, right? But see this guy right here? You shut that, open up the pre-valves. No, that doesn't make sense, because then you'd see flames coming out of the bottom of the rocket engine. Dude. If your pressure inside the pipe decreases, it can collapse. A pipe is better at resisting bursting than collapsing. Yeah, okay. If you need a stronger pipe for withstanding a lower relative pressure inside of the pipe, hopefully that made sense. No, yeah, Novus, I got you. So it's probably not correlative there. Yeah, John, it is. Dude, that is wild. Yeah, of course, it's crazy. So let me think about this, right? What is this here? Let me look at let's look over here. So who made this first and foremost? So we can give credit where credit is due for this beautiful diagram. Elise Imsilov. Very, 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 very awesome. Let me take a look. So, guys, we don't know if this is accurate. It could be. It says on the image. Oh, yeah. Elise Maslov. Okay, cool. There you go. So keep in mind this is Raptor 1, not Raptor 2. Let me look here. The other side of that is they increase the pressure inside the tank that the downcomer runs through. That could create a condition that could crunch the downcomer due to the relative pressure inside versus outside the pipe. Yeah.
Discovery, go at throttle up.
Subma Vans, 58-month resub. Thank you. Trying to look to see if I can recognize, like, so your pre-valves are right there. See the two pre-valves? What do the pre-valves do? They tap off some of the liquid oxygen and liquid methane. Actually, staged liquid. Yeah, liquid oxygen, liquid methane. We could just say that. That's fine. And they tap off from the compressor to get the gas generators working. The gas generator is attached to the pump. When you have a gas generator attached to a pump like this, and the gas generator goes into the engine, that's a power head. The space shuttle called this a power head, but you could call it, power head. It could just be a turbo pump. You could call it a turbo pump, but it's a gas generator with a fluid impeller attached to the top. So the interesting thing about this, fellas, is that the space shuttle engine is not that far off from this. It's not that far off. The space shuttle doesn't have this part up here, though. The space shuttle just has a regular gas generator. It looks like this on both sides, except the fluid impeller from the liquid oxygen goes right to the injector plate instead of staging it like this. So I'll give a little bit of a word on how Raptor works here. Raptor takes some of the methane. The methane goes through the cooling channels on the nozzle. It gets heated, right? It gets turned to gas. Okay, you heat it up, it turns to gas. And then it finds its way into this combustion chamber. This combustion chamber has a LOX liquid oxygen injector. So you're spraying liquid oxidizer into a gaseous fuel. That creates a very energetic explosion. That explosion goes through here, turns a turbine wheel that turns the fluid impeller up here. So turbine, pump, turbo pump, right? The gas generator is right here. So this and this is basically half of a turbojet engine. Turbojet engine would have a compressor up here, right? And it would be attached to that. This is a turbo pump. So you have a gas generator that spins the turbine wheel, and then from there, you have the gaseous methane tap off. Yeah, hot gas. Yeah, that's the autogenous pressurization. Space Shuttle has something like that too. So then what they do here, guys, is the mixture is all off here. We're way far from stoichiometric. This gas generator runs extremely fuel rich, meaning there's way more methane than oxidizer going in. Look at the size of the tube here. That's liquid oxidizer, and this is cold gaseous methane, right? So you get good atomization when you have gas and liquid like this. Okay, now that spins the turbine, and then you get the extremely fuel-rich gas mixture going in here. So there's a little bit of oxidizer left in here. They use some of the oxidizer to turn the turbo pump, right? They get an explosion. And then the hot gas goes in here. They basically preheat the fuel going in. It's in gaseous form. Once again, better atomization. If you can spread the methane out and turn it into a gas and do the same thing with the oxidizer, when they combine, when gaseous methane and gaseous oxidizer find their way into the engine, you get a very energetic explosion. So, on the flip side of that, you have the same thing with the liquid oxygen. The liquid oxygen pump, or the LOX pump over here, right, has methane injection into it. It has hot gaseous methane getting injected into liquid oxygen here, in the gas generator. The gas generator's in between the impeller and the turbine. See that? The gas generator is right here. The gas generator over here is there. It's in front of the turbine wheel. But it's also in front of the fluid impellers. So you have gas generator, turbine, impeller. This one is turbine, gas generator, impeller. See the difference? So they hit methane into here, basically something analogous to a combustor on a jet engine. So you get your gas generator here, and that spins the turbine wheel, and then this thing outputs extremely oxidizer rich mixture, an extremely oxidizer-rich gas mixture here. So you have an extremely methane-rich gas mixture here, and then you have an extremely oxidizer-rich gas mixture here, and then they put that in the combustion chamber, and then they blow that up. Very, very energetic reaction. The reason why is because you're getting way better atomization with this. So, once again, it's rocket science, a little bit on propellants here. Gases are spread out. They're more spread out than a liquid, but you're getting liquid propellants, right? If you can spread the gas mixture out as much as possible by blowing it up, an explosion generally blows up, right? It doesn't blow in, right? Or combustion, I should say. You get the gases to spread out, and you do the same thing with the oxidizer. You get the oxidizer to spread out, and then you combine those two, right? And then you explode it. You get a really energetic reaction. Now, here's the thing. In order for this whole thing to work, these turbines need to be spinning at like 60,000 RPM to sustain this type of rocket engine. They need to be spinning extremely fast. Right? So my guess here, based off of what we kind of talked through here, what's the D on the diagram? Eh? I'm not sure. Drain. It's a drain line. It's drain line, sorry. My guess is that they shut the main fuel valve and they kept the pre-valves open to keep you guys are saying it right. If you shut the fuel valve and you keep the impellers going, right? If you keep the pre-valves going, right? It's basically going to cough out and it's going to burp. The engine's going to burp. Once again, rocket engines do that. They burp if you don't gas purge this thing out, right? If you keep the pre-valves open and shut the main fuel valve, the entire system kind of depresses and you get that gnarly explosion right there. You're going to get a lot of residual propellants getting burped out the bottom of the rocket engine. Literally what Booster 7 did, but on purpose. Remember the Booster 7 static fire? Not that one. No, not that one. This one. Headphone users. Headphone users. Headphone users. Yeah. It burps. The engine burped. Dude, that's an anti-lag system. They're using the pre-valve. I'm pretty sure. Like, I mean, once again, I gotta ask Rocket Guy about this. I could be 100% in the wrong, and don't get me wrong, not a rocket scientist, probably am. But if I'm understanding this right, they literally have an anti-lag system for Raptor. That's unbelievable. They have a freaking... They keep the pre-valves open, and the thing... Like this. Let me see. It's a pre-valve. That's what it is. The pre-valve, not a pre-valve. They keep the pre-valves open, and the engine burps, and that explosion that comes out the bottom when they shut the engine off keeps the turbines spinning. I just don't know how they do that. How are you doing that if there's fuel? If the fuel lines are still pressurized? But if they have valves in the tanks, they shut those too. And if you shut that and keep the pre-valve open, it'll drain the lines instantly, and you'll get that residual pop out the bottom of the engine. Like this. All right, Forge, you said that this was loud, so let me just go here and... How can the lines drain if the main valves are closed? If the valves are upstream a little bit, Phil, there's going to be a little bit of residual inside of the lines that go to Raptor, just enough to make a quick burp. And that explosion, if they have the pre-valves open, will have the impellers drained. So they're not closing the main fuel valve. They can't be. If they close the main fuel valve, you wouldn't get methane into the combustion chamber, and you wouldn't get that fireball that comes out the bottom, right? But see, that would mean that they need to stop the engine, pre-valves open. So right when you're throttling down the engine, you shut the valves to the tank, pre-valves stay open, main fuel valve stays open. Raptor drains it, you get a fireball coming out the bottom, but since the pre-valves are open, everything stays spinning, right? And then what you'd have to do after the engine shuts off is shut the main fuel valve and then shut the pre-valves and repress the system and then start it again. How does it not explode? How does it not explode? How does that not blow itself up right off the test stand? How does it not do that? Honestly, I have to talk to Rocket Guy about this. He's the propulsion guy. Because he actually works on this stuff in real life. Not Raptors, but because Raptors built different. Indeed. 2020, I mean, a lot of people often wonder why Elon insists that Raptor needs to be able to handle like 300 bar chamber pressure. Well, so, ready? Main valve, or tank valves off, right? Tank valves off, pre-valves open, main valve open. Pumps are spinning, pre-valves closed, main valve closed, tank valves open. Holy dude. How does that not explode? How does it not pop? See, what I'm talking about here with, the sequence of opening the valves is going to prevent hammering. That's going to prevent the hammering from happening because you're using the residual propellants that are in the rocket engine to keep the pump spinning by opening the pre-valves, closing the tank valves, and keeping the main valve open, hence the fireball. It's freaking anti-lag for a rocket engine. It's an anti-lag. So, okay, cars do this, fellas. Cars with turbos do this. I don't know if you guys ever heard or seen a car drive down the road, and it's just like, the car's like, it's shooting fireballs out the back. That's an anti-lag system. What they do is, with an anti-lag system, you're running fuel rich in a car. So fuel gets into the exhaust after the piston does its thing. Fuel gets into the exhaust and you reignite the exhaust, and that creates that burp. That's what the backfire is. And that burp helps accelerate the gases going out of the exhaust. And because the turbine wheel is in line of the exhaust, it keeps the turbo spooled. That's why it's called anti-lag. Because it negates turbo lag, right? Because with a car, right, when you step on the gas, the engine has to start moving the exhaust gases enough to be able to spin the turbine or spool the turbine. When you spool the turbine, the compressor starts to compress the air. That's when the engine makes power. If you have a small displacement engine and a big turbo on it, right, and you step on the gas, it's going to take a second to spool the turbines. The engine has to start moving the gas fast enough to be able to spool the turbines, and then the turbines are going to deliver an insane amount of boost really, really quick. That's called turbo lag, because turbines have to spool and engines really don't. I mean, throttle response is quick with an engine compared to a jet, right? You ever played Flight Sim and you throttle up and it takes a second to get going? Same thing. That's the turbofans taking a second to spool. It happens. Now with rockets, I said that the rocket engines have pre-burners instead of afterburners, right? The pre-burners use the same principle because it's still a turbine wheel. So Raptor has an anti-lag system built into it. It's similar to that, only instead of liquid, you're moving gas, which is crazy. And in this particular case, the pre-valves are working like the valves on the engine. Are the turbines stopping during the relay? No, Nifodia, they have to be able to keep them. They have to keep them spinning.
Discovery, go at throttle up.
Shizrek, 21 months. You have to keep the turbines spinning. And I'm telling you, that fireball that burps out at the end of the first ignition, that's what's keeping them spinning. They deliver more fuel by keeping the main fuel valve open and the pre-valves open. I mean, it's probably a little bit more complicated than that. There's not just 3 valves that control the entirety of Raptor. There's a ton of them. I mean, look at this diagram. There's a lot of valves in here. I'm talking about basics for stage combustion cycle. Yeah, no, that's ridiculous. Those ones stay open when they shut the engine off the first time. They keep that open, and they keep that open, and it evacs all of the methane that's in here. It evacs, right? And because the pre-valves are open, the gas generators, the 2 gas generators are still on, right? But because the liquid methane has a lot longer of a distance to travel than the liquid oxidizer, you're going to get that explosion is going to be fuel rich, right? So you should see a sooty cloud, right? Look what happens when they shut it off. Sooty cloud. Holy shnikes. See? Look. So much more methane in there. All this black stuff right there is soot. That's carbon. It's unburnt carbon from the methane because methane has carbon in it. Right? The line is literally longer. It's going to take more time to evac all the methane out of the system. And once they get a big pressure drop past the main fuel valve, they probably close it. Leave the pre-valves open for a second. Shut those. You get the big sooty explosion coming out the bottom. And then as soon as that explosion clears and the turbines start falling in RPM, right? You put more fuel back into it. You prime the whole system over again. Dude, how does that not break it? If that's even close to right, that is an absurd feat right there. You can't just do that with a stage combustion cycle engine. Meanwhile, SpaceX is over here. Ha ha ha! Stage combustion, go brrrr. So then where is the high pressure propellants that the pumps are pumping going if they're still spinning? Well, Builder, if you open up the tank valves again and repress the whole system after you shut the main fuel valve and shut the pre-valves, right? Now the pre-valves got to stay open the entire time. So where's the high pressure? Yeah, once you start flowing propellants back into the fluid impeller, it's going to start slowing it down. It'll start slowing the thing down. But it's not going to slow it down. It's not going to slow them down to a standstill, which is why the second restart didn't take as long, because that's it. That's got to be it. The power head shafts are still spinning. They don't purge it out with nitrogen. They don't stop them. They use a residual explosion to keep them going, right? And then they start flowing the propellants back into the engine and then restart it. Now, I'll be honest with you. If what I'm thinking about is correct, the longer the period of time between restarts, the more impressive this gets. Can the pump spin and not get damaged with no propellants? They can, Builder. They'll start to warm up. They'll start to warm up. So yeah, I mean, Yes, they will. After that's what I'm trying to tell you. After a certain period of time, the propellants, the shafts will start heating up, and when they start, because they don't have the cold propellant going over them, right? And if they start heating up, then you're gonna have a little bit of a problem. Yeah, Hellfish. Yeah, I know, right? Like, I know. When I say you can't do that, I mean, like, if you tried, the implication there is that if you tried to do this with a shuttle engine, it would explode. Like, guaranteed explode. Is there any scenario where they need to restart a Raptor that fast? Well, a couple of viewers in chat have suggested this, Jazos, but if one of the engines breaks during landing, they can basically anti-lag the second engine and start it right back up again and do a nice, easy landing. That's the only scenario that I can really think of. Can I just... Sorry if this is a dumb question, but do these turbines spin on bearings? Yes. It's not what you think, though. Raptor has hydrostatic bearings. Hydrostatic bearings. Think about that for a second. Hydrostatic bearings. So it's using a liquid that doesn't move. Cherry on top of the relative simplicity of Raptor 2. It's ridiculous, Hellfish. It's ridiculous. That's SpaceX's gift to humanity thus far. Even if Starship like never works, these rocket engines, Raptors have so many applications, dude. So many, dude. Could you imagine making like an aerospike with Raptor's power packs? So that's how they survive vacuum. Yeah. They have hydrostatic bearing. So a car, the bearings on like an engine, on a crankshaft, those are not hydrostatic. They are hydraulic bearings, right? But that's oil that the oil seeps in, and the motor's constantly circulating and basically pouring oil over all the moving parts for temperature and for, ease of movement. This does that with no moving, with hydrostatic. So a liquid bearing that's staying in one place. Kennedy Space Center. Teams have cleared most large operating facilities with minimal damage reported. Additional facilities will be assessed tomorrow. Civil and contract employees will return to work tomorrow, Friday, September 30th, in accordance with their supervisor's guidance. If the liquid doesn't move, it's a solid, yeah. Motorkid, the bearings on Raptor are basically submerged. They're submerged in liquid. And that's how the thing can spin so fast. That is... Apollo's gyros used liquid nitrogen bearings. Yeah, unbelievable. I wouldn't be surprised, Hellfish, if that's what Raptor did, but yeah. You gotta remember, Mutter, you said, if liquid doesn't move, it's a solid. What freaking liquid are they using that can get down to minus 400 Fahrenheit and stay a liquid and not turn to slush? Raptor has methane going through it. How is that, dude? How liquid helium? I know Raptor does have helium. Liquid helium, the propellant itself. You could use the prop itself, but doesn't hydrostatic doesn't hydrostatic mean you're not using the propellant as a bearing, or am I not thinking about that right? Oh, drain. There's a drain right there. No, it is using, yeah, it's using the propellant. It uses the propellant itself. Yeah, okay, so what I said in the past was correct. It's an open loop hydrostatic bearing. Yeah, but oh wait, hold on. I'm stupid because okay. Hydrostatic bearing. Fluid bearings are a bearing in which the load is supported by a thin layer of rapidly moving pressurized liquid or gas between the bearing surfaces. Since there is no contact between the moving parts, there is no sliding friction, allowing fluid bearings to have lower friction, wear, and vibration than many other types of bearings. Hydrostatic doesn't necessarily mean that well, no, wouldn't that be a hydrodynamic bearing then? Let me read. I gotta read the technical definition. Hydrostatic bearings are externally pressurized fluid bearings where the fluid is usually oil, water, or air and is pressurized by a pump. Hydrodynamic bearings rely on the high speed of the journal, the part of the shaft resting on the fluid, to pressurize the fluid in a wedge between the faces. Wow! That's cool. No, it is hydrostatic. That's not what Raptor does, I don't think. It might. Fluid bearings are frequently used in high-load, high-speed, high-precision applications where ordinary ball bearings would have shortened life or cause high noise and vibration. They are also used increasingly to reduce costs. For example, hard drive disk motor fluid bearings are both quieter and cheaper than the ball bearings they replaced. Yeah, Aqualex, basically that's what I'm saying. Yeah, that's what they do. It's just sequencing the valves in the right order to keep the pumps freewheeling. That's right. But that means the bearings risk going dry. Maybe there's an auxiliary feed to keep that from happening. Well, who knows how accurate this diagram is, right? But Aqualex, if the bearings have a tap from the main fuel line, which it looks like they do, if they have a tap from the main fuel line, then reintroducing liquid in over the impellers right here, reintroducing cryogenic liquid is going to relubricate the bearings. It's nitrogen. Look at the main pipe. Where's the nitrogen? Gray. No, the nitrogen is used to start the impellers. Spartan, I don't think why would you have a gaseous oxygen drain valve here then? And why would you have a liquid methane drain valve right there coming out of the bearing? See what I'm talking about? This thing. See that? See that sucker right there? Why would you have that? And then why would you have that? I don't even think that's the same gray as the nitrogen, but I could be wrong. It could be, it just says nitrogen. It doesn't say liquid or whether it's liquid or gas. That's crazy, dude. Every time we learn something about this engine, I get more and more impressed. Not that I wasn't impressed to begin with, but that's just, sorry, small screen. It looked like the rate. No, it's all good, Spartan. It's all good. I actually asked you because I was trying to see if you saw something that I didn't, because I tried to explain this to you guys when we first looked at this footage, and then I got confused. So I said, screw it. I don't know what's going on here. And then we tried to figure it out. I think we got it. I think we're close. I think. We could be way off. I have no idea. They could just have a magic start button and boop. It must float on the evaporating methane. Yeah. Isn't this a diagram for Raptor 1? It's from 2019, so yeah. Raptor 2 could be changed a little bit. Like, for instance, if you had that drain valve, if you had the drain valve for this going into this line right here, you could basically use the bearing waste to reprime the engine. Oh, man, dude. We're probably never going to get the answers to this, fellas. But I'd be very, very interested to know that. That would be really cool. The turbines need to be primed before spinning up. Yeah, you can't dry fire the turbine, MotoKid. This kills the rocket engine. And then comes the simplification for the same capability. Do you guys... Hey, fellas. I have another question. You guys remember the NASA spaceflight self-destruct testing? But that's what they seem to be doing, dry firing the turbine. They got to reprime the system, Aqualux. They have to reprime it. It has to be reprimed. You wouldn't be able to get that quick of an ignition that way. So my guess is that once they start putting the liquid over the turbine impellers, or over the fluid impellers, the turbines will start to spool down, and they basically try to fast fill it as quick as possible, and then restart the engine before the turbines spool down all the way, which is why the second relight on that Raptor footage was shorter than the first one. That's my guess. Check my link to the Raptor 2 diagram. Yeah. I mean, the Raptor 2 thing still has all the stuff that I'm talking about. Raptor 2 still has the pre-valves, and it still has the main fuel valve. It still has everything here. But also, this self-destruct testing footage, guys, let me see. I want to see if these engines burp before they explode. Do that burp thing where it shoots all the methane out. Yeah, it did do it, but it didn't look the same. Oof. Oof. I don't know if it was intended self-destruction, to be honest with you. It does burp. It does burp. It doesn't look exactly the same, but that's because I think they got the temperature or something. Something else went wrong. Guys, I can't prove it. We'll probably never know. But I'm pretty sure that these destructive tests are them trying to restart the engine. The shutdown timing wasn't right to keep the turbines freewheeling. How does relay capability land? The only thing I can really think of, T-Man, is landing. You could, Raptor lights 3 engines, it starts slowing down, it shuts one off, lands on 2, and then maybe shuts another off and lands on 1. If one of the other engines don't relight correctly, right, you already have an engine that's basically primed because the turbines are freewheeling. You just start that right back up and land. Yeah, MotoKid, or the boost back. Yeah, the boost back is the other one. So, like, after main engine cut off, the thing turns around and fires its engines immediately. Yeah. Also, remember that the V2 engine cold flowed liquid oxygen and alcohol to a low pressure gravity fed burn with the turbo pump at idle for several seconds as a final test before spooling up the turbine and launching. Yeah, I mean, thermal conditioning. Yeah. A lot of rocket engines do that, Ingenuber. The thing is doing that after you evac the turbines. Could this be used for rapid start and an abort? I don't know. I'd have to see more of it. I think we figured out what happened with that one test, but... Because, fellas, look. Up here, when the engine shuts off, you see the venting right there. They vented in the same spot during that start-stop test. There's some kind of vent system up here that depressurizes something. But after the engine failed, they depressed the fuel tank right there. Now, that Raptor restart test depressed in the same spot, but not the tank. Look. Watch up here. See it up there? But they didn't depressurize the tanks. What the fuck? Yeah, Aqualex, yeah. I don't think that destructive testing was on purpose. I think that's what they were trying to do. They were trying to restart it and the engine didn't like it. Because look, right when the engine starts to turn green and the engine overheats, if the plume coming out of a Raptor engine turns green, the engine's overheating. Right when the engine starts to turn green, you see the vents up there. See it? There's the burp, but the engine popped and it aborted the test. Curious how you would relight the shuttle engines if you could. Shuttle engines could be relit, T-Man. The problem is that they have the starter motor for the shuttle engines is launch pad side. Gas gets flown through the TSMUs. Remember the tail service mast, the thing that SLS has problems with? The shuttle had those as well. Very similar design. To start the three main engines, they shot liquid nitrogen to spin up the power heads on the shuttle engine and get it to start. You need the launch pad to start the engines. Shuttle engines are one start and done. There's no relight capability. If you wanted to have relight capability with a shuttle engine, you could do it. You just have to bleed the engines. But even if you bled the engines again, or somehow were able to do that while the thing is flying, the shuttle would need some type of onboard pressure vessels like Starship. Like the Starship has the pressure vessels in the chines on Super Heavy.
Discovery,
to be able to shoot that nitrogen back into the system to spool the pumps again. There's no way to spool the turbines on a shuttle engine once they shut off. Perhaps all those tests were getting the shutdown timings worked on that relight. Darius, that's what I think, dude. I'd have to talk to some people. But I think that's what's going on here. I think they didn't get the shutdown timing right to freewheel those turbo pumps. And if they didn't get the shutdown timing right and they basically dry fired the turbo pumps, guess what happens? The thing overheats. And that's what happened here. The thing overheated. It ran engine rich, which means if it's green, that means it's burning up the combustion chamber because Raptor's getting too hot. If the propellants aren't staged going into Raptor at the right temperatures because the bearings are overheating, right? Yeah. Then you're gonna have a bad day. Shady, 30 months. Thanks, man. You would need COPVs on the shuttles. The shuttle already had COPVs, T-Man. In fact, the shuttle program is what COPVs are a byproduct of the shuttle program. Yeah, the shuttle was the first launch vehicle to have composite overwrap pressure vessels on it. It was made out of they were made out of titanium and wrapped in carbon fiber. They were the first ones to do it. Shuttle program was the first ones. I'm talking about you'd need to have a ton of nitrogen to restart the shuttle engines, you'd need to have a ton of nitrogen sitting in the back of the shuttle somewhere, and that would screw with your payload capacity. And what the engineers on the shuttle program thought is, why do you need to restart the shuttle engines? You only need to fire them once. Once main engine cutoff happens, they don't need to be fired again, so why would we carry all that extra stuff around? Super Heavy's a little bit different. It has to come back and do that landing thing. Now, don't get me wrong, the shuttle does too, but the shuttle has those winglings on the side to help it do that. Considering the difference in methane and LOX line lengths, you'd actually have to shut the methane off first, but doing that you run the risk of running too lean during shutdown, and threading the needle would be hard. And Aqualex, check this out. Here. Wrap your noodle around this. Look at how methane rich this thing is coming out here. When they shut it off, there's a big city fire that comes out the bottom of the engine. Ready? The engine burps. See, look at all that extra methane. Look at all of it. You could see the gaseous methane in the atmosphere. See it? That dark cloud, and that all burns off. Dude, they I think they're freewheeling the turbines. That's nuts. It's a freaking anti-lag system. How is that possible? Oh my goodness, that's insane. That blows my mind, dude. That dude, I don't know how that doesn't happen without the engine blowing itself up. But also at the same time, that seems to be what has happened multiple times when they've tried to do this. And Builder, you're right, they do make the same noises. That doesn't sound like a regular Raptor shutdown. It's a higher pitched honk. EO, 55 months. See last if you want, thanks. Yeah, no, I got you. I was just getting to it. Ridiculous. I'm gonna go see if the RPE books have anything on this. Well, Aqualex, I think that the mixture gets rich because if you just look at this diagram, the plumbing for the methane, because it's cooling the nozzle, is way longer. Either that or they leave the main fuel valve open for an extra second here to drain methane coming from up here. Could be. So whatever happened with the J2, the auction, the blocks went for over like $1,000, dude. I can't afford that. If it was like $500 or like $100 for all the lots, then maybe. But last time I checked, with a lot of time left on the auction, they were all above 1,000 or something, or it was total above 1,000. I forget. The point is that I couldn't afford it. 20,000 for just one lot. Yep. Crap. Anyway, a little bit on propulsion there, fellas. You want to play some hearts? Guys, I'm going... So what? It's 9 o'clock now. We have a good amount of time here before Firefly goes to launch. I figure if they're targeting 3 in the morning for their launch time, probably start coverage like an hour before that. So it's 9 o'clock now. If coverage begins around 2, that means we got 5 hours of solid after hours gaming time. Good for Hearts of Cities. I already played Cities, so I kind of want to play. Hearts, man. I really want to see how that new DLC works with the airplane designer and whatnot. Reading some stuff here. All right, so the reason why I'm doing a whole marathon stream in the first place, guys, till Firefly, is because this is their second orbital attempt. This is a big deal. Another commercial company is going to try to put their hat into the ring of commercial companies that have, or they're going to try to join the elite company of commercial companies that have made their way into orbit. Only a couple of commercial entities have done this. SpaceX, obviously. Rocket Lab, Astra, in their own